Hi, I'm Jasmine, and I'm an experienced tutor. Today I'll be taking you through some of the past questions for the Joint Admission Matriculation Board examination. I hope you enjoy my tutoring. Question 1 says which mathematics question type paper is given to you, and you would just mark the type that you have. In this case, it's going to be type B. That's just so you know. Alright, so here we have question 2, and it says find R if 6R7 to base 8 is equal to 5, 1, 1 to base 9. And then it gives you some options. So what this means is if we have the number 6R7 base 8 and 511 base 9. So 6R7, R is in place of some other number. This could be like 687 or something, or 637. But we don't know yet. We have to solve for R, okay? So remember that when you have a number to a base, like this, what it means is that this right here is representing 7, 8 to the 0 powers. This is R, 8 to the 1 powers, and this is 6, 8 squared. So essentially what you're going to do is just multiply these and add them. So 6 times 8 squared plus R times 8 to the first plus 7 times 8 to the 0 is going to be equal to 5, and we're going to do the same thing on this side. Remember, the exponents go 0, 1, and 2. So it's going to be 5 times 9 squared plus 1 times 9 squared, to the first, plus 1 times 9 to the 0 power. Okay, so anything to the 0 power is going to be 1. So to start simplifying, I'm going to say that this is the same as 7 times 1, or just 7. 8 to the first power is just 8, so this is going to be 8R. Okay, and then over here we're going to have to do 64, because 8 squared is 64, times 6. It's not that bad of a calculation, so we get 24 here, and then it's going to be 384. Okay, so we have 384 plus 8R plus 7 on this side. And we're going to set it equal to, so over here we're going to have to do 81 times 5. So this is just going to be 5, and this is going to be 40. So 405 so far. And then 1 times 9 to the first power is just 9. And 1 times 9 to the 0 power is just 1. So we have 405 plus 10 is going to be 415. Okay? So we're this far. And then I'll change colors so that things don't start to get mixed into themselves. So I'm going to start simplifying. So I'm going to say 384 plus 7. Alright, so if I were to add that, I'm combining terms here. So this is going to be 11, and bring up the 1, 9, 391. So 391 plus 8R is equal to 415. And then we're going to subtract the 391. Okay, so now we have 8R is equal to, so this is 24, there we go. And then we divide by 8, and we get R is equal to 3, which would be your answer right here. So here we have question 3, and it wants us to simplify. And so you're going to see this word of appear in the middle of our mathematical equation. And so you're going to say, what is a word doing in the middle of our math? Well, of means to multiply. So we're going to have 3 over 4 times 4 over 9. Okay? And then it says to divide by 9 and 1/2. But we can simplify this. So we can say 9 and 1/2 is equal to, we're going to turn this into an improper fraction, so we don't have to work with the mixed number amongst all these other fractions. So 9 times 2 is 18, plus 1 is 19, and we leave it over 2. These two fractions are exactly the same. This is the improper version, this is the mixed number version. Okay, and then instead of dividing by 19 over 2, because that can get confusing, we're going to say multiply by 2 over 19. So this is the reciprocal. Okay, reciprocal. So hopefully I spelled that right. And so what that means is to take 1 over the number. So 1 over this would flip the numbers, so it'd be 2 over 19. These two things are not equal, but you can use it over here, and instead of dividing, you would multiply by the reciprocal. So that makes things simpler. And then we're going to do the same thing with this part. So 1 and 5 over 19. So we're going to take 19 times 1 and then add 5 to give us 24 over 19. Okay, so then now we're going to take the reciprocal of this too, so that we can multiply by 19 over 24. Now that we have parentheses all the way through, we can, let's see if they only erase, we can ignore these. Sorry, now that we have multiplication all the way through, we can ignore the parentheses. Okay, so 3 goes into 24 8 times. Okay, and then 2 goes into 8 4 times. Okay, so then, and the 4s, they will cancel out themselves, and then the 19s will as well. So we're left with 1 times 1 times 1 times 1 over 1 times 9 times 1 times 4. So 9 times 4 is 36, and we're left with 1 over 36, which is your answer right here. So here we have question 4, and it says a student measures a piece of rope and found that it was 1.26 meters long. If the actual length of the rope was 1.25 meters, what was the percentage error in the measurement? So essentially what you want to look at is if you don't know an equation for this, it's fine. You can reason yourself through this one. So the actual length over here was 1.25. Okay, and then the student found that it was 1.26. Okay, so you're going to subtract to figure out just how off the student was, and you're going to find that the student was 0.01 off of the measurement. Okay, 0.01 meters, I guess. So what we're going to do then is we're going to say how much is this of the real thing. So we're going to say 0.01 over 1.25. Okay, and once you have this, you would end up with a certain number, and that would give you what fraction of it the student was measured out wrong. But what you want to do really is you want to multiply that by 100. So that can give you a percentage.
To simplify further, we get rid of the decimals by multiplying 0.01 and 1.25 by 100. This will give us 1 over 125 times 100, and that is equal to 100 divided 125. To simplify further, we will divide by a common multiplier of both the numerator and denominator, which is 25. 25 into the numerator is 4, and 25 into the denominator is 5, which is 4 over 5. Since our answers are in decimals, we convert 4 over 5 fraction into decimals, which will 5 us 0.8. Our final answer will be D.
So here we have question 5, and it says at what rate will the interest on 400 increase to 24 in 3 years reckoning in simple interest? So simple interest uses this equation. Interest equals principal times rate times times. This is our principal. Our rate is what they're asking for. They said at what rate. And then they're telling you that it's going to be in 3 years, so that's going to be our time. And then they said that the interest will increase to 24. Okay, so this is our interest. So essentially what we're going to do is we're going to set it up. 24 is equal to 400 times our rate, which we don't know yet, times our time, which is 3 years. Okay, and then so we're just going to go ahead and solve for our rate. I'm going to say 400 times 3 is like that. And here we have 24 times r over here. Okay, so then to solve for r, of course, we're going to do 24 divided by 1,200. Okay, and if you do the math, that's about 0.02, which transfers over to 2%. Okay, so that's your answer right here, B. So here we have question 6, and it wants us to compare, it gives us, first off, two comparisons, P to Q and Q to R, and then it says to find P to Q to R. Okay, so what we're going to do is first we're going to sort of assign values for each of these variables. So first they give us P to Q and they tell us that it's 2/3 to 5/6. So what we're going to do is we're going to say, well, P is essentially 2/3 here, and Q is 5/6. Okay? And then we're going to do the same thing with this one. Okay, so, oh, sorry. They said that Q to R is 3/4 to 1/2. And so Q is 3/4 here. And then R is 1/2. And so here you'll notice that Q sort of has like, its Q is 5/6 and Q is 3/4. To compare all three of them together, what we need to do first is multiply these two values. So for Q, I'm going to say 5/6 times 3/4. Okay, so this is 1 and that's 2, so 5 times 1 is 5. 2 times 4 is 8, and now Q is 5/8, okay? Alright, so going back to comparing PQR. So what we're going to do here is we're going to say, so P to Q to R. So, P is 2/3, Q is 5/8, R is 1/2. Before we can continue comparing these, we need to find a common denominator between all three of them. Okay? And so the best way I can figure out to explain that to you is, imagine that I had some sort of pie or pizza, and I had different slices of this pizza, but this is the way that I'm telling you. I'm telling you this person has 2/3 and 5/8 and 1/2, and what's the comparison? And it's hard to compare them this way. It'd be easier if you just could compare them where each slice was about the same size, you know? And so basically what we want to do is we want to find a common denominator. So to do that, it's a lot like finding a common denominator when you want to simplify fractions when you're adding. And so basically I'm going to say 3 and 8 both go into 24, and 24 is an even number, so 2 goes into it as well. So now what I can say is I can convert 2/3 to something over 24. And so what I did to get that was I said 3 times 8, right? So I have to do that to the top as well. 2 times 8 is 16. So there I have 16 over 24, and that's going to stand in for P now. Okay, so now 5 over 8. Again, I want to convert it to something over 24. 8 times 3 is 24. So 5 times 3 is 15. 15 over 24. Now the 1/2, you can reason yourself through this one, or you can just do the same process we've been doing. But basically, well, what's 1/2 of 24? That's 12, right? Because 2 times 12 and 1 times 12. So there you go. Now we have 12 over 24. So your comparison is going to be 16 to 15 to 12. And see, so once you have this common denominator, you can just sort of ignore it, and it just becomes 16 to 15 to 12. You don't have to worry about the denominators anymore. And so what that would be up here in your answer is actually B. So here we have question 7, and it says that, it wants us to evaluate 81 over 16 to the negative 1/4 power times 2 to the negative 1. And I've written in already some parts that are hard to read, I thought, just because it didn't quite transfer over that well. So this is negative 1/4, and this option over here says 1/3. But anyway, let's go get into the math of it now. So here we have 81 over 16, and it's to the negative 1/4 power. And then over here we have 2 to the negative 1. So this might seem a little bit daunting at first if you don't remember what to do with negative exponents. And then it might also confuse you because you see this fraction exponent, and so you get lost and you're like, what do I do? So first off, what you want to know is when you see a negative in front of an exponent, it just means to flip the number. And so what by that I mean to take the reciprocal. So reciprocal, did I spell that right? Okay, so reciprocal means to take 1 over your number. And so essentially what happens is it just turns into x over 1, and it's just, it's just x. And so what you want to do first, and I'll demonstrate first over here. So let's say we're taking the 2 to the negative 1 power. That just means that you want to say 1 over 2. Okay? And so, sorry, I think I overdid it over here. You just take 1 over your number. So you have your number x, it's going to be 1 over x. Okay? So here we have 2, we took 1 over 2. Okay? This is the reciprocal of it. And so that's the second part of the problem. But what about this part over here? Okay, let's just focus on 81 over 16. And sorry, okay, I got ahead of myself here. Okay, 81 over 16 to the negative 1/4 power. So you can do this either way. You can start by taking the 4th root, which is what the fraction means, or you can start by flipping the number, or taking its reciprocal, I mean. It doesn't really matter. Either way, it'll still work. So I'm going to start by taking the reciprocal, okay? So first, I'm going to say 16 over 81 to the 1/4 power. There, I got rid of the negative sign, okay? So now we're just focusing on this part right now. Okay, so when I say to take it to the 1/4 power, I'm telling you to take it to the 4th root. And so basically what that means is whenever you see a number like written like this, the square root of x, you could also see it written like this, x to the 1/2 power. Okay, so if you see x to the 1/3 power, then that's the same as saying the cubed root of x. I'm going to make that a 3. Okay? So when you see the x to the 1/4 power, that's the same as saying the 4th root of x. Okay? And it's not too hard to do with the numbers that we have right here. So what is, and also don't forget that when you're doing division, you can sort of split it up. So I'll rewrite it. The 4th root of 16 over 81, which is this, sorry, I wrote that back, 81, which is the same thing as saying the 4th root of 16 over the 4th root of 81, okay? So what's the 4th root of 16? What times itself 4 times gives us 16? Well, that's 2, okay? Because 2 times 2 times 2 times 2 will give us, let's get to 2, will give us 16, okay? And what happens, how do we get that, how do we get 81 using the same process? Well, that'll be 3, okay? 3 times 3 times 3 times 3. And to know these, you really just have to work a lot with numbers, and you really have to be able to recognize this. It's hard to just sit there and work through it. So work with exponents, practice knowing what 2 to the 4th root power, or excuse me, 2 to the 4th power is and 3 to the 4th power. That'll help you if you can recognize it by sight. But moving on, so here we have reduced this number. We've simplified the 81 over 16 to the negative 1/4 to just 2/3. Okay, so that's much easier to work with. We're going to plug it back in up here. Okay, so this reduced to this, and this became this. Now we can just go ahead and multiply. And when you're multiplying fractions, you can do this. And now we're left with 1/3, which is our answer over here, A. So here we have question 8, and it says, given that log of 2 is 0.3010 and log of 7 is 0.8451, evaluate the log of 112. So when you first look at this, you might feel a little bit lost because you wonder how you're supposed to use what they gave you to arrive at what they want. But basically, it's just going to be a matter of looking at this, and working with the rules of logs. So log of 112. Okay, remember that you can make a log. How do I want to say this? You can change, not necessarily change, but you can break up this number. So using these two numbers. Okay, so 2 and 7 can go into 112, and in fact they'll multiply to 112 if you have several factors of 2. So it turns out that if you have 2 to the 4th power, which is 16 by the way, and multiply that by 7, you will get 112. Okay, so 2 to the 4th power and 7 are suddenly very important. And so the log of 112 is the same as saying the log of 2 to the 4th times 7. And using rules of logs, we can pull this apart again, but this time we're going to say that when you multiply in logs, you can split it apart to make addition. And it's going to look like this. It's going to say the log of 2 to the 4th power plus the log of 7. Okay, and so maybe now you can start to see how this is going to be helpful to us in finding our answer, because we already know what the log of 7 is. That's right here. Okay, now we have to work with this 2 to the 4th power. Okay, this is not a pretty 4, but you can understand what I'm trying to say here. So another rule of logs is that the exponent can be taken out. So this exponent, we can say 4 times the log of 2. And these are exactly the same thing. And now we're just going to say plus the log of 7 that we had already found out before. And now we really have something we can work with, because we know what the log of 2 is. It's right here. So now what we're going to want to do is we're going to say 4 times the log of 2, which is 0.3010, plus the log of 7, which is 0.8451. Okay, so now I'll try to get you through the multiplication, and hopefully I won't get caught up in the multiplying. Excuse me. So here we have 0 times 4. Okay, that's just 0. 4 times 1 is 4. 4 times 0 is 0. 4 times 3 is 12. And we're pretty much done, except that we have 4 numbers behind a decimal point. So we have to say 1, 2, 3, 4. Okay, so this is our answer for the first part, 1.2040. And we're going to be adding it to this number, so I'm going to line them up, 0.8451. Okay, and we just add, and this is our answer, 2.0491, which is right here. So here we have question 9, and it says rationalize 2 root 3 plus root 5 over root 5 minus root 3. And so what you want to remember is that you're not allowed to have square roots on the bottom of fractions. And so that's not just some arbitrary rule. There's a big reason for that. And the idea is that when you have a graph and you try to take the square root of something, it can be this or that, and sometimes it's just when it's on the denominator, it comes out with problems on the top, and there's issues, and so yeah. So we want to rationalize. We have 2 square root of 3 plus the square root of 5, and here's the square root of 5 minus the square root of 3. So when you see something like this, it's really important to notice a pattern that you can do. And so here's the denominator, and we're going to multiply it by something that looks a lot like the denominator, except there's this major difference where instead of subtracting, we're adding. And the reason why we do that is so that when we do this, it becomes it's sort of a difference of squares type thing. And essentially what we'll end up with down here is just 5 minus 3, and so I'll show that to you. So just working with the denominator right now. Okay. So just working our way over. So here's our first one. The square root of 5 times the square root of 5 is just 5, right? Okay, and we keep going. Plus square root of 5 times the square root of 3, and then minus the square root of 3 times the square root of 5, and then minus the square root of 3 times the square root of 3 is just 3. Okay? And so you'll notice that this and this are essentially the same thing, and we're subtracting one of them from the other one, so they cancel. And we're just left with 5 minus 3. So now we've gotten rid of the problem of these on the bottom and on the denominator. So that helps us simplify things a little bit. So we know the denominator is going to be 5 minus 3. But now we have to work out the numerator, which could be some work, but it's not that bad, and it'll lead us to the right answer. So I'm going to delete all of this right now, so that we can work on the other part. So, working on the numerator, 2 times the square root of 3 plus the square root of 5 times the square root of 5 plus the square root of 3, okay? So, we're just going to start, to do it the same exact way we did before. 2 times the square root of 3 times the square root of 5 plus 2 times the square root of 3 times the square root of 3. And I'll simplify after I've worked all this out. I just find it easier to first start with the expanding and then simplifying. Okay, so we did the first, the outer, now the middle. Okay, I'm just going to go ahead and simplify here, because I know that the square root of 5 times the square root of 5 is just 5. And then the last is just going to be square root of 3 times the square root of 5. Okay, so when you're working with square roots, you are totally allowed to combine them as long as you're multiplying. So this is 2 times the square root of 3 times 5, which we know is just 15. Okay, so here we have 2 times the square root of 15 plus, okay, the square root of 3 times the square root of 3 is just 3, right? So 2 times 3, which is 6, okay? And we keep going. Here we have 5, okay, keep going. And this is, again, the square root of 3 times the square root of 5, which we did over here, and we found was the square root of 15. So remember, we're only working on the numerator right now. After we finish simplifying this part, we have to go back and put it on top of our denominator, all right? So here we have all of this. Well, let's combine like terms. Okay, 6 plus 5 is 11, okay? And then here's 2 root 15 and root 15. That combines, and so I'm just going to get rid of that one over here. So that's 3 root 15, right? If I have 2 root 15s and 1 more root 15, I have 3 root 15s, okay? So 3 root 15 plus 11, and we're going to put that over here. 3 times the square root of 15 plus 11 over 5 minus 3. Just one more simplification we want to do here. 5 minus 3 is 2, okay? So 3 root 15 plus 11 over 2, and that's our answer over here. That's A. Okay, so we have question 10, and it says express the product of 0.21, 0.34 in standard form. Okay, so what you want to do is first off find out what the answer is, okay? What is 0.21 times 0.34? Okay, so remember that multiplying decimals is a lot like multiplying any other number, except that at the end there's an extra step where you count how many numbers are behind the decimal, okay? So 4 times 1 is 4, 4 times 2 is 8, and then we're going to put our 0 down because we're going to be moving on to the next step, right? So moving on to the next place of the numbers, we're going to say 3 times 1 is 3. Okay, and then 3 times 2 is 6. And then we're going to add everything. So this is 4, 8 plus 3 is 11, and 6 plus 1 is 7. And so remember, before we finish, we have to count how many numbers are behind the decimal places. This is 1, 2, 3, 4. So we're going to go 1, 2, 3, and don't worry that there's not another number here. You can just add a 0. There are 4. There we go. Okay? So now we have to deal with putting it into standard form. And so basically, standard form doesn't deal with all these extra zeros in the front of the number. Okay? Because if I give you a number like 0.000851, what's really going to be important to you are these last 3 numbers, not the zeros. Okay? That's only going to be important to you in knowing, okay, well, how many zeros are behind it. You don't need to see all of the zeros. And so what I would say is, well, it's just 8.51 times 10 to the negative 4th. Okay, so we're going to do that over here, but I'll explain it to you where I get my answer from. Okay, so when I say times 10 to the negative something, I'm telling you to move the decimal point, essentially, well, you're going to make it smaller. Okay, if I have the number 21 and I say times 10, you can compute that pretty easily for me, and you're going to tell me it's 210. That comes naturally to you. But what if I say 21 times 10 to the negative 1? Okay, so what you want to do there is you want to, so what you did here, even if you weren't trying to do it, what you did here is you moved the decimal point 1 place over and you added a 0. This time, you're going to move the decimal place 1 place backwards, okay? So now, this is 2.1, okay? But generally, when you're using standard notation, you only want like 7.14 times something, okay? So just one number in front of the decimal point. Okay. So here we have 7.14. How is this number related to 0.0714? How are these two numbers related? They're pretty similar. The only difference is, let's see here, right here, right? What's the decimal place moved 2 places, okay? So this is, to make these numbers the same, I have to say times 10 to the negative 2, okay? This and this are the same thing now that I've added this, okay? Because there's a difference of the 2 decimal places here, okay? And eventually it'll become more intuitive to you. If you get some practice with this, you'll be able to look at it and like I said earlier, this is 8.51 times 10 to the negative 4. And the way I looked at that was there's 1, 2, 3, 4 numbers before I reach to that decimal point that I want, you know. And then, so over here there was 2 numbers before I reached the decimal point that I wanted, so times 10 to the negative 2. Okay? And that's your answer right here. Alright, so here we have question 11. And it says, which of the Venn diagrams below represents P prime intersection Q intersection R prime? So there's a few things that we need to understand before we can dive into the question and find the answer. So first, this symbol, okay? I know it's not very well drawn, but this means intersection. Intersection. Okay, there we go. And then if you were to see this would be union. Okay, and they're different in terms of what you want to do with them. And so, so let me explain first off the difference between these two, just so that if you ever run into them later on, you'll know what to do, okay? So union and intersection. Union can be described a lot like, I guess I could call it, well, this is just a metaphor, okay, so don't take it too far, but a union can be considered like let's say a marriage. So in a marriage, two parties come together, and I mean, this could be a marriage of a company even, you know. Two parties come together and they bring what they have, and they consider what was once each of theirs to be both of theirs. And so a lot of times it'll be written in terms of sets, and we'll see if, okay, there we go. That's really, okay. It'll be written, I'm having a hard time drawing the set symbol today. Okay, so let's say for the first union, or excuse me, the first set we're considering in our union has the numbers 1, 2, and 3, and the second set has numbers 3, 4, and 5. Okay, so this is this could be considered like one set, okay, and this is the second set, okay, and so the same, it could work for anything, okay, it doesn't have to be numbers, it could be, so let's say we're bringing two people together, okay, one person has a blender, and I don't know, one person has some silverware, and one person, the same person also has a microwave. Okay, and then the second person, this person has, I don't know, this person has a vase and a computer, and they also have a microwave. Okay, in a union would consider everything to now be one set, okay? So if we're working with numbers, it would be 1, 2, 3, 4, 5, okay? You don't need to count the 3 twice because there's only, I mean, it's the same thing. It's still 3, so you don't need to count it twice. It's just 1, 2, 3, 4, and 5. And then in our metaphor over here, we would have our blender, and we would have the silverware, and I'm wishing I didn't use such big words now, and a microwave, okay, and the vase, and the computer, and I wouldn't have to list the microwave once, or excuse me, I wouldn't have to list it twice because we already have that, okay? So basically, this is a union. You consider everything together, okay? An intersection, though, is much different, okay? It's very different. Okay, so when we're talking about intersection, and if you have troubles remembering what the symbols look like, just know that union looks like a giant U, and so that's union, and the other one is intersection, okay? When I'm talking about an intersection, and we go back to our sets of numbers 1, 2, and 3, and 3, 4, and 5, these two sets, an intersection of these two sets would only be the number 3. Okay, that's it. And in our previous example with the blender and the stove and the blender and the silverware and all that, the only thing that would be included for the intersection, if we were only talking about that, that would be the microwave that both of them had. Okay? Alright, so now we understand what that means. Let's take it a step further. So here I've drawn a circle, and it has another circle inside it. And this is B and this is A. Okay, so I wrote here, A is the complement of B, and I may have used the wrong complement. Sorry. So we want, basically what I want you to understand here is that there is a hole. This outer circle, I didn't really give it a name, but I guess I could call the outer circle C, okay? B is a part of C, and I guess so is A. And B's complement is A. Together they complete C. Alright? So going down here, now I've written it in the more standard notation that you will see. And so here is one whole box, okay? And here is a circle A, and the outside is called A prime. A prime completes A, and it makes the one box, okay? So the probability of getting A, this is all ties back into chance, okay? So the probability of getting in the space A plus the probability of getting in the space A prime is 1. Okay, it's always going to add up to 1. And so here we go. This is one piece, and this will be its complement. So when you see A and A prime, you know that we're just talking about one piece and its complement, okay? So now we've pretty much got all the building blocks that we need to answer the question. So P prime intersection Q intersection R prime. Okay. Remember, intersection is more stringent. It's more strict on what we can include. You can only include the things that are common to all three, okay? So I've rewritten the picture, redrawn the picture over here, and so we're looking for P prime intersection Q intersection R prime. Okay. So I'm going to use color to help us see what's actually going on here. Okay. So here is Q. Okay, we'll start off with that. Okay, Q. What's Q? Well, this is Q. This is Q, and this is Q. Okay, these are all Q. Okay, but not only do we want Q, we want Q and part of P. We want, you know, at least the complement of P. Okay, so let's look at what comprises that. Okay, obviously this entire circle would be P, but we want the part of P that that's the complement of it. So that would be this section in here. Okay, you can see it's taken up by other parts, but it completes all of it, right? All right, and then not only that, but it has to be involved in Q. Okay, so that's these two parts. These are both involved in Q, and they complete P. Okay, so now we also want to look at, so go ahead and, I guess I'll color this. Okay, so now we want to look at R prime. Okay, so again, since we're only looking at the intersection, we want the part of R prime that is also included in Q and in P prime. Okay, and so I have made a mistake. Let me fix my mistake real quick. The complement of P is not in here. This whole circle is P. I just outlined over here that if this whole circle is A, the outside of the circle is A prime. Okay? The entire rest of this square is P prime. Okay? It's also, you could also consider it, you know, Q prime and R prime. But the point is, the entire rest, even let me go back to purple. All of this, everything out here. Okay, everything outside of the circle of P is P prime because it all adds up to 1. Okay, so, but what part of it is included in Q? Okay, well that's out here. Okay, this is technically P prime, right? And this is well, this isn't really, I wouldn't consider this actually, because this is still a part of the circle of P. Okay, so now let's go into R prime. Okay, now I'll use another color for R prime actually. This color. Okay, so this is R prime. This is the circle of R, right? That's the circle of R. Everything outside of it is R prime. Okay, how much of that outside how much of all about here is included in Q? Well, that's this section right here. Okay, so the only part here where all three colors are involved is all of this. Okay, so our answer is going to look like this section. Okay, only this part of Q includes P prime and R prime. And that would be our answer over here, which is A. So here we have question 12, and it says, in a series of 50 newspaper readers, 40 read Champion and 30 read Guardian. How many read both papers? And then they give us some options. So to answer this question, we want to use our knowledge of Venn diagrams and of intersections, okay? Oh, that's not very, hold on. Try that again. Okay. Just assume that both circles are the same size. I'll try it one more time. See if I can get the circles to match sizes. Okay, well, you know, that's pretty close. So, essentially, okay, so here we have 50 total newspaper readers, okay? 40 read Champion, 30 read Guardian. How many read both? Okay, so what you want to do here is label one of these Champion. The other one will be the Guardian, Guardian, okay? And of course, in between is where they intersect, the inclusion of both. And so some people might be tempted to say, well, here's 40 and here's 30, and they kind of like do some weird mental math, and they say, oh, there's a difference of 10, and so they want to answer 10, but that's not right, okay? Don't do that. What you want to do is you want to draw this first, and then you want to, let me make sure I'm labeling them right, 40 red Champion, okay? So here's 40 out here, sort of. But remember that in between here is an intersection, okay? So you have to count this as 40 minus x, because this in here finishes this out here. Alright, and then so here we have 30, but this is also 30 minus x, okay? Because there's an intersection of the two of them, okay? So now we just go ahead and solve for x. What you want to do is you want to look at all this and then say, remember, if you saw number 11, there's a total of 50, and so all of this combines to make the total. So we're going to have 40 minus x plus x plus 30 minus x. All of that is going to equal 50. Okay, and now we're just going to solve for x. So we're going to have 70, and here we have negative x and negative x, and so we're going to get minus 2x plus x equals 50. Okay, so we're going to have 70 minus x equals 50. Okay, and then what I'm going to do is I'm just going to subtract 70 from both sides. We get negative x is equal to negative 20, and then divide by, put that backwards, divide by negative 1 for both of these, right? X equals 20. That's your answer. Okay, so here we have question 13. And the question says, make Q the subject of the formula if, and then it gives us a formula. Okay, so what they mean by make Q the subject of the formula is they want us to solve for Q. Okay, so I'm going to rewrite the problem here so I can work with it. M over 5 times x plus Q plus 1. So the first thing I'm going to do is I'm going to say subtract 1. B minus 1 is equal to m over 5 times x plus q. Okay, so I've rewritten the equation below so that I can continue to see what I'm doing. Okay, I'm gonna draw some lines here so that I know I've moved on. Alright, so here's this next part. So now what? So what I'm going to say is I'm going to say to multiply by 5. Okay, so what I'm going to do is I'm going to multiply by both sides by 5. Okay, so once you've done that, you're going to rewrite the equation. You just want to keep things clear so you don't make mistakes. If you can handle not rewriting it every time, it's fine, I guess, but it's really best if you just find what works best for you for maintaining clarity. Okay, so now what I want to do, well, before I could do a few things here. I could divide by m, and then I'd be left with x plus q over here, but then I would have to subtract x to get to q, and the thing is, you'll notice all of the answers are given in a form where m is the denominator. And basically, well, I'll show you both ways, okay? So let's do the way I just said. So divide by m. Okay? That cancels, and then we're left with 5 times p minus 1 over m is equal to x plus q. And then I subtract x from both sides, and I say 5 times p minus 1 over m minus x plus q. Oh, sorry, minus x is equal to q. So I would have to find a way to simplify this and make this in a form where m is in the denominator so I can compare my answer to theirs. So what I want to do is basically just find a common denominator, which is not too hard to do. When you find a common denominator, you say, well, here's a denominator I want, and I need x over it. So if I'm going to say I want x, technically it's x over 1, right? So x over 1, I want it to be, somehow I want it to get over m, right? To do that, I would multiply both the top and the bottom by m. So now I have x times m over m. Alright, so now this is 5 times p minus 1 minus, yes, it's still minus because we have minus over here. Okay, minus mx over m is equal to q. Okay, so you could do it that way, or you could also, you're up here, let's say you're here, you're at 5 times p minus 1 is equal to, over m is equal to x plus q. And I think I jumped ahead of myself. Okay. Let's say you're still here. Oh, okay. There we go. Let's say you're here. Okay. So let's see what happens if we distribute m. And let's distribute the y where we're at it. So we'll have 5p minus 5 is equal to mx plus qm. Okay? So now I'm going to say subtract mx. So now we have 5p minus 5 minus mx is equal to qm. Okay, now divide by m. Okay, so now we have 5, okay, now we have 5p minus 5 minus mx over m is equal to q. And so these two answers are actually exactly the same. It's totally okay, whichever one makes the most sense to you. Just remember to distribute this at the end, okay? And then you'll have the same answer, and you'll get which one is it? Looks like this one. Actually no, it's not that one. Sorry. It's 5p minus mx, right? 5p minus 5 minus mx. 5p minus 5 minus mx. Okay, so it's this one. And yeah, and so just make sure that you watch your steps while you're working. Keep clarity with you, okay? And then you'll arrive at the same answer. It just depends on what you feel like doing. Okay. So here we have question 14, and it says if 9x squared plus 6xy plus 4y squared is a factor of 27x cubed minus 8y cubed, find the other factor. Okay, so what we have to realize here is, first off, they're telling us that this polynomial is a factor of this one. Okay, so what does that mean? If I tell you that 5 is a factor of, say, 50, what I mean is that I could take 50, divide it by 5, and I'd get 10. And I wouldn't have any type of remainder, because it goes into it evenly. So when it goes into it evenly, it's a factor, right? 5 times 10 is 50. So we're having the same idea here. So basically what they're saying is, we can take 27x cubed minus 8y cubed and divided by 9x squared plus 6xy plus 4y squared. And we should get an even answer with no remainder, which means that we'll find the two factors of this number. Okay, so let's start doing this. Polynomial long division is a lot like long division that you would do without the variables. There's just, you follow the same process, okay? It just looks a little bit more complicated because of the variables. So let's get started. You want to start first, just look at the first term, okay? And you really want to order, when you have polynomials, you want to order them so that the highest degree is first. But, in this case, we have x cubed and y cubed, so we're just, it's fine the way it is as long as either this one's first or this one's first. Alright, so let's get started. Oh, but if this was first, this would have to be, okay? But let's just get started with how they gave it to us, okay? So 9x squared going into 27x cubed, okay? And that's exactly what it sounds like. So if I took 27x cubed and I divided by 9x squared, what would I get? Well, we know that 27 divided by 9 is 3, and x cubed over x squared will cancel and we'll just get x, right? So 3x. And we put that right up here. Next, we're going to take 3x and multiply it through all of this, okay? So 3x times 9x squared, we just said was 27x cubed, right? Then we do 3x times 6xy, okay? So 3x times 6xy. 3 times 6 would be the 18, right? So we're going to say plus 18, and then the x and x would make x squared, right? And then we're left with y. So plus 18x squared y. And then we do it again over here. Plus 12xy squared. Okay? And I'm going to erase this scratch work over here so it doesn't confuse me. Okay. Next, we're going to do just like in long division without variables, we're going to subtract this. Okay? So 27x cubed minus 27x cubed is 0. And then, okay, so what about this? So 18x squared y. What am I subtracting it from? Well, I'm technically subtracting it from 0x squared y. Right? So when I do the subtraction, if this is on the bottom, then I'm just going to say minus 18x squared y. And then it's the same thing here. The xy squared, it's the same thing as 0xy squared up here. And so when I subtract, I get negative 12xy squared. And then don't forget about this term as well, minus 8y cubed, okay? Because it was already negative 8y cubed, and I brought it down over here. Okay, so sometimes when say you're learning this from a book and it's teaching you to do the long division, sometimes what they'll tell you to do is if you have extra terms, put these zeros in so that you can know what you're doing, and then put this at the end of the number so it would look like this. Let me use a different color so you can see. I'm just showing you an example right now. So it would have looked like this: the 27x cubed minus 0x squared y minus 0xy squared, and then I would have said minus the 8y cubed. Okay, and then I would have done my subtraction, and then that way you can remember to bring the 8y cubed to the bottom when you're done subtracting, so you don't get it lost over here in your math. But if you can keep track of the numbers, then just go with it, okay? So here we are at this point, and so just like if you were doing long division with as you learned it with just numbers and no variables, next we would say, okay, let's take this into this new answer that we got down here. So 9x squared into negative 18x squared y. Okay, and if you can't do that in your head, you can always write it off to the side. And I guess I'll use a different color since this is a scratch trick. Okay, so here we have negative 18x squared y, and I'm dividing it by 9x squared. Okay, so here's a negative sign, so it's going to be negative, right? 18 divided by 9 is 2. The x squareds will cancel, and I'm just left with y. So negative 2y. Oop. Okay, so negative 2y. So now I'm going to multiply this number by everything here, okay? So negative 2y times 9x squared is negative 18x squared y. Then I do it again with the 6xy. 6xy times negative 2y. It's going to be negative 12xy squared. Okay, so that's this 6 times negative 2. That's where the negative 12 came from. X, and there's no x here, so I put down 1x. Y times y is y squared. Okay, and then one more term. The 4y squared times negative 2y is going to be negative 8y cubed. And now we do our subtraction, okay? And so remember that when you're subtracting negative numbers, it basically becomes addition. And so I'll show you that with a different color. So now I'm going to basically just be adding all of these, okay? So negative 18x squared y plus 18x squared y is 0, right? This is also 0, and this is also 0. So there we go. We've just finished the problem, right? So our answer is up here. 3x squared minus 2y, which is an option right here. So question 15 asks us to factorize completely, and it gives us this equation up here. So what we want to do is basically the best way to go about this is to start simplifying something. So here is, I'm going to rewrite it, x cubed plus 3x squared minus 10x divided by 2x squared minus 8. Okay, so what you want to do first is recognize where you can pull out factors or numbers that are carried throughout the entire expression. So what I mean by that is, here is x cubed plus 3x squared minus 10x. All of these have an x in them. I can pull out an x to start simplifying things. Okay, so this is going to be x times x squared plus 3x minus 10. Okay, and on the bottom, I'll notice that I have 2x squared minus 8. 2 goes in evenly into both of these. I can pull out the 2. 2 times x squared minus 8. Sorry, not minus 8. Nope. 8 divided by 2 is 4. Minus 4. There we go. Okay, so now what? Well, now we look at what's inside of here. Both of these are actually fairly easy to factor. So what you want to do is you want to first just look at what's inside of this parentheses. X squared plus 3x minus 10. This is one of those polynomials that'll, when you factor it, it'll look like this, and there's an x here and an x here, and you just have to figure out the numbers here. So what you want to do is you want to say x times, and so we're going to have 2 parentheses and be an x here and an x here. Okay, so you want to say what two numbers will multiply to negative 10 but add up. Did I write that down wrong? 3 plus 3x squared. Okay, multiply to negative 10 but add up to 3. So what you want to do is you say, well, negative 10, so that could be that could be -2 and 5, right? So I would say -2 plus 5. And then on the bottom, okay, if you look at this, this is what we call a difference of squares. Alright, so when you see x squared minus 4, you can think the same thing as saying x squared minus 2 squared. Okay? This is a square. And when you what happens is that when you had it in this form, there was a +2 here and a -2 here. Okay? And then what ended up happening is you multiplied out, you said x squared minus 2x plus 2x minus 4. And then these two terms canceled and you were left with x squared minus 4. And this happens with anything that will end up being a square. So it could be like this. It could be x squared minus 16, which is the same thing as saying x squared minus 4 squared. So there you go, there's a difference of squares. So it would have been x plus 4 times x minus 4. Okay, and you can try that with a few others and you'll see that it works out that same way. And so basically what I'm telling you here is here we have x plus 2 times x minus 2. And then you'll notice that there's two terms here that will cancel out, right? Because now, since we're multiplying everywhere, we can cancel terms out easily. X minus 2 and x minus 2 will cancel, and so here we have x times x plus 5 over 2 times x plus 2. X times x plus 5 over 2 times x plus 2. So that would be this one right here. Alright, so here we have question 16, and it says solve for x and y if x minus y equals 2 and x squared minus y squared equals 8. So what you want to do first is write out the important information that they gave you. So x minus y equals 2 and x squared minus y squared equals 8. Okay, so what we can do here, and you can just, it takes some practice, but you'll be able to notice it eventually and just look at it. We can use substitution. We can solve for one of these variables and then just plug it in over here and then solve for one variable instead of two in this equation. So what I'm going to do is I'm going to say x is equal to y plus 2. And the way I did that was I said add y to both sides. So here we have x is equal to y plus 2. So now we're going to plug that in right here. So they want us to use x squared. So we're going to say y plus 2 squared. Okay? And then minus y squared is equal to 8. So now we just go ahead and work with what we've got here. So the y plus 2 squared. Alright, well there's a form that you can follow, but I'll show you why you get that form. So y plus 2 squared is the same as saying y plus 2 times y plus 2, right? You get y squared plus, so here's y squared, and then you're going to do plus 2y again, and then plus 4. So you're going to get y squared plus 4y plus 4. Okay, so if you'll notice, what it ends up being is it ends up being the first term squared, the last term squared, that's these, and then you're gonna get like 2 times one of these multiplied together. Okay, so practice a little bit with that, and then you can start finding a pattern, and then you can use it to multiply faster when you do these problems. Okay, but so here we have it in expanded form: y squared plus 4y plus 4 minus y squared, right, because I put that back down there, is equal to 8. Okay, here's y squared and here's negative y squared, and so they cancel, And so you have 4y plus 4 is equal to 8. I'm going to subtract 4 from both sides. 4y is equal to 4. I divide by 4 to solve for y, and y is equal to 1. So here we have the first part of the problem. And so now we're going to use this to help us get our x. So if y is equal to 1, I can plug it back in over here. So here they told us that x minus y was equal to 2. So I can say x minus 1 is equal to 2, because I just solved for y down there. So x is equal to 3. So and if they wanted an ordered pair form, remember ordered pair is x comma y, so it's going to be 3 comma 1, which is right here. So here we have question 17, and it says if y varies directly as the square root of x, and y is equal to 3 when x is equal to 16, calculate y when x is equal to 64. So first I want to explain to you where I got this expression from. Okay, so it says y varies directly as the square root of x. So when you're reading these problems, you really have to look at the wording and write out exactly what they tell you. Okay, because some people would look at this and they might mess up right here. And if you make a mistake before you've even really started with the math, if you make a mistake when you're writing out the expression that you're going to use, you're going to mess up your answer entirely. Okay, so they said y varies directly. So this symbol means it's proportional to, and so that's just telling you that y will always change according to x. Okay, and then it also tells you that it has the square root of x. So here is the square root of x. Okay, and then I put a k in there because it tells us that it varies directly. So that means it's proportional to, but it's changing by a constant term every time according to the square root of x. It's not that y equals the square root of x. It's that y is changing according to the square root of x. So you have to multiply it by something every time. Okay? So here we go. Here's our equation, and then they told us that y equals 3 when x equals 16. So let's plug that in. Okay? And we can go ahead and use an equation with the equal sign now, because we're solving for k essentially at this point. Okay, so here is k times the square root of 16. Okay, so let's go ahead and solve for k so that we can move on to the next part of the problem. So 3 equals k times the square root of 16, which is 4, right? So then what you're going to do is you're going to say, well, you're going to divide by 4 on both sides, right? So you're going to see, you're going to divide by 4, okay? So k is equal to 3/4. And then we're going to say calculate y when x equals 64. So k we know is equal to 3/4. So now we're gonna rewrite our equation. Y is equal to 3/4 times the square root of x. Now we know k. So we can go ahead and just plug the numbers that they gave us. So when x is equal to 64. So y is equal to 3/4 times the square root of 64. So what's the square root of 64? Well, that's 8. So y is equal to 3/4 times 8. And remember, a whole number 8 can be written as 8 over 1. Okay, so then that'll help us do some simplification here. And then we get 3 times 2 is 6. And this simplified here, so our answer is just 6. Alright, so here we have question 18, and it says that x is inversely proportional to y, and x is equal to 2.5 when y is equal to 2. Find x if y is equal to 4. So we want to start by writing the right formula before we get going. Okay, so x is inversely proportional to y. So that means that okay, so why did I write 1 over y? When I say that something is inversely proportional, I'm saying that one of them is, one of them is inverted. Okay, so when we invert a number, we take its reciprocal. We take 1 over that number. Okay, so these two are inversely proportional. And we also know that x is not 1 over y. It's proportional to 1 over y. So what x is x is equal to k times, k times 1 over y. Okay, this is what they mean when they say directly proportional to. So that means I can simplify this a little bit and say that x is equal to k over y, right? So now I have this part, and now I want to solve for k. Okay, so x is equal to 2.5 and 1/2. And then I'm going to write my k, I don't know what that is yet, and then this says that happens when y is equal to 2. Okay, so now I'm just going to solve for k. And so the way you want to do this is, first off, you want to change this number into a fraction, into a top-heavy fraction, sometimes what we call it. So right now it's a mixed number, and the way we change it back is, first we multiply these two numbers. 2 times 2 is 4, and then we add the top number. So that's 4 plus 1 is 5, and we leave it over the denominator. Okay? 2 and 1/2 is the same as saying 5/2. Okay? And then we set that equal to k over 2. Now we continue solving for k, so we're going to multiply both of these sides by 2, right? That's going to cancel. And then that's going to cancel. And we're left with k is equal to 5. Okay, and then, so now what you want to do is you want to say, well, now we know k, so x is equal to 5 over y, right? So that was our k. Here's our expression. I plugged in 5 for k. Okay? So now we're going to solve. They want us to find x if y is equal to 4. So x is equal to 5 over 4. Okay? So that's fairly simple. Here's 5 over 4. But if you'll notice, that's not any of our options, and that's because we didn't simplify yet. This is a top-heavy fraction, and so what we need to do is we need to say 5 divided by 4. Okay, well, 5 divided by 4 is 1 and 1/4. Right? Because if we did that, if I said 5 divided by 4, you would put the 1 here, you would subtract 4, and you'd be left with 1. And you wouldn't say, well, you could say 1 remainder 1, but really what that is 1 and 1/4, right? That's where I got the 1/4 from. Okay, so we have 1 and 1/4 is our answer now, and that's an option right here. So here we have question 19. It says, for what range of values of x is 1/2 x plus 1/4 greater than 1/3 x plus 1/2? So what we want to do is, first off, well, I'm going to write it out here so I can have numbers written out to work with. 1/3 x plus 1/2. Okay, so the first thing we want to do is simplify a little bit. 1/2 times x. Remember that when I say 1/2 times x, I can, and this notation is a little bit confusing, so I'm going to use my little dot symbol to say multiply, times x. Okay, 1/2 times x is the same as saying 1/2 times x over 1, right? So you can put a whole number over 1, it's still the same thing. So now what I get is x over 2. Okay, so that'll make things easier to work with later on. So I'm going to simplify this. This is now going to be x over 2 plus 1/4 is greater than, and I can do the same thing here, x over 3 plus 1/2. So the next thing I want to do is start getting the like terms on the same side. Or you can also think of this as isolated x. So I want to get the x's on the same side of the equation. So I'm going to subtract x over 3 and put it over here, and I'm going to subtract 1 over 4 and put it over here. Okay? So here is x over 2 minus x over 3 is greater than 1 over 2 minus 1/4. Okay, so what I did is I said minus 1/4 to both sides of the inequality. Okay, and I said minus x over 3. Okay, and that's how I ended up with where I am right now. So now what I can do is I can make this problem even easier to work with by finding common denominators for this and for this. That way I can compare these two more easily and I can start solving for x. Okay, so a common denominator for 2 and 3, a pretty simple one, is 6. So remember that I have to change the top parts to match what I'm changing to the bottom. So what I mean by that is I'm going to make both of these to be over 6. But to change x over 2 to be something over 6, I have to multiply both the top and the bottom by 3. So now this is 3x. Okay? And then over here, when I'm changing x over 3 to something over 6, I have to multiply the top, the bottom and the top, the denominator and the numerator, by 2. So now this is 2x. So minus 2x, because we got a minus sign here. Okay? And now I go and I do the same thing over here. So I can say now I have 1/2 minus 1/4. Okay, let's simplify that. So I could do this. I could say, well, common denominator is 4, right? So 1/2 converted into fourths would be 2/4, right? And then just minus 1/4 still. Okay, so this is the same as saying 2 minus 1 over 4. And then so what I get is just 3/4. Okay, no, not 3/4, not 1/4. And I could have gotten that just from looking at this. 2/4 minus 1/4 is 1/4. Okay, so I do the same thing over here. So 3x minus 2x is just x, right? So x over 6 is greater than 1/4. Okay, so now I'm going to multiply both of these sides by 6, so I can solve for x. 6 over 4, but I want to simplify my answer, so x is greater than, both of these are divisible by 2, so 6 divided by 3 is 2. Nope, yes, 6 divided by 2 is 3, 4 divided by 2 is 2. So x greater than 3/2 is what will satisfy the equation, and that is our answer. So here we have question 20, and it says solve the inequalities. -6 less than or equal to 4 minus 2x less than 5 minus x. So what you want to do is notice that there's two parts of this total inequality here, okay? So we're going to work with them one at a time so we can solve for x and then put it into the format that they want us to. So here's -x less than or equal to 4 minus 2x. And what we're going to do is we're just going to solve for x. So I'm going to subtract 4 from both sides. We're going to get -10 is less than or equal to -2x. And then I'm going to divide by -2. And remember that when you divide by -2, when you divide by a negative and you're working with inequalities, the inequality sign is going to change. So now it's going to be 5, because -10 divided by -2 is 5, and it's greater than or equal to x, okay? This can also be written as x is less than or equal to 5. Remember that the open side of the inequality sign will always face the same number, okay? And some people have troubles. They see these two signs and they cannot tell which is which. And they realize that they're different, but it's hard to associate one with less than and one with greater than. And so the way that I was taught very early on was I was taught to think of this as the mouth of some type of animal. Okay, so let's say it's the mouth of a crocodile, or maybe the mouth of a dinosaur. Okay, so here we have a dinosaur, and the mouth. Think of a dinosaur. What would they want to eat? They would want to eat the bigger number. So the open end, the mouth, will face the bigger number, which in this case for us is 5. So if we rewrite this inequality so that x is in front, the open side still has to face the number, okay? It's not going to face the variable, it's going to face the number. That's how we decide where to put, or where to orient the numbers with the inequality sign, alright? So these two are the exact same thing. You can write it the same way, and that'll come in handy later. So let's work with the next part. So this is 4 minus 2x is less than 5 minus x. Again, we're going to solve for x. So I'm going to add 2x to both sides. We're going to get 4 is less than 5 plus x, because negative x plus 2x would give us just 1x. Okay, and then we're going to subtract 5, and then we're going to get negative 1 is less than x. Okay, and so when you're working with addition and subtraction, you leave the inequality sign as it is. Okay, it doesn't change like when we divide it by a negative number. So now we have this inequality and we have this inequality. How do we combine them? Okay, well, you'll notice up here the options that they give you, they use this format. X is in the middle and you have two numbers on either end. So what you want to do is you want to put the lowest number to start. So we have negative 1 and we have 5. Negative 1 is obviously the smaller of the two. So we put it here. And we put x in the middle. Okay, and 5 is on the other end. Now we have to remember the relationship that they started with. Okay, the relationship between negative 1 and x here was that x was greater than negative 1. So that means we're going to leave it like this. Alright, and then after that, we want to figure out the relationship between x and 5, right? So the relationship here was that 5 was greater than x. Okay, so we leave it as it is, because remember, in terms of over here, if you want to use my dinosaur metaphor, it still wants to eat the bigger number. No matter what, 5 is bigger than x over here. So we're going to say greater than or equal to. And remember to pay attention if there's an equal to sign or not. So then this is our answer right here. X is greater than negative 1 and less than or equal to 5, okay? So we look up here. And what do you know? That's one of our options. So here we have question 21, and it says find the sum to infinity of the following series. And then it gives us 0.5 plus 0.05 plus 0.005 plus 0.0005. And so what we need is this equation right here. So the sum to infinity is a over 1 minus r, okay? And a is going to be our starting point, and r is going to be our rate of change. So our starting point right here is 0.5, okay? So there's part of our equation. So here's our sum. And 1 minus, let's find what r is. So to find the rate of change, okay, what you have to do is realize that the rate of change is 0.05 divided by 0.5, which is equal to 1/10. Or you could, and I find this way much more intuitive, you could just look at this, look at the numbers. So here we have 0.5. Then it changed to 0.05. Then it changed to 0.05. Sorry, 0.005, okay? So the way I see this is the decimal point is moving over, or the number, I guess, the number of interest is moving over by 1/10 every time. So you know that there's the tenths place, tenths, right? And then there's the hundredths. And it's changing, the 0.5 is being kept, but it's moving over 1/10 every time. Okay, so the rate of change is 1/10, alright? So now we just work with what we have here. So I'm going to simplify, and so here we have 0.5 and 1 minus 1/10. Remember that we're taking away from a whole, which means that 10 over 10, because that's one whole, minus 1/10 will give us 9/10. Okay, so now it's 0.5 over 9/10. To make this easier to work with, I realize that 0.5 is the same thing as saying 1/2. So now we have 1/2 over 9/10. And when we divide fractions, sometimes it's easier to just multiply by the reciprocal. So here we have 1/2 times 10 over 9. Then we do some simplification here, and 2 goes into 10 5 times, and so here we have 5 over 9. And that's your answer. So here we have question 22, and it says the third term of an arithmetic progression is -9, and the seventh term is -29. Find the 10th term of the progression. So what we want to do is use this equation over here, but I've started drawing sort of a representation of what it is that they're talking about, so that you can see why it is that we use this equation. If you were taking the test, you would not need to draw this out. It would not be necessary. You could just use this. But I needed to draw this so that you can understand where this comes from. So it's more like intuition to you, and then it's not just memorization, and you'll understand why it is the way that it is. Alright, so this equation is a plus d times n minus 1. A is our starting point. Okay, so I'm going to put a over here. That's our starting point. D is the common difference. Common difference. And what that means is that for this to be an arithmetic progression, there has to be a difference of change that's the same for all of these. So it's a common difference. And n minus 1 is used because what ends up happening is that this common difference will be a change. N will be the position of the number, and it'll always be one less than that position of the number. So, and you'll see how this fits in once we find what a and d are. So, let's solve for a and d. We know that the third term is -9. So that means we're going to say a plus d, because we don't know what d is yet, times, so our n, this is the nth number, we're in the third term, so we're going to do 3 minus 1, and it's equal to -9. Okay, so I'm going to rewrite this. A plus 2d is going to give us -9. Okay, and then we're going to set up the same equation, but this time using the seventh term, which is -29. So a plus, and so 7 minus 1 is 6, so it'll be 6d is equal to -29. Okay, and now we can use these two as a system of equations to solve for one of the variables. So what I'm going to do is I'm going to make all of these negative. Okay, so essentially what I'm doing here is I am multiplying by -1 throughout. So that means that this is going to be +9. And so what I'm going to end up doing is I'm going to add these two so that these cancel. We have 4d is equal to -20, and then we'll divide by 4 so that d is equal to -5. So there we have our d. So now let's find a. So let's plug it back in. Let's plug it back in. So a plus -5 times, I'll plug it in for this equation up here, times 2, right? Because it's 3 minus 1 is 2, is going to be equal to -9. So a plus -10 is going to give us -9, and then we add 10 to both sides so that a is equal to 1. Alright, so now we have a, and now we have d. And so next, so now we're going to say that, well, now that we have a and d, we can easily find the 10th term. Okay, we're just going to use our equation again. So our equation is a plus d times n minus 1. Okay? 1 plus -5 times n minus 1. The nth term that we want to solve for here is 10. So 1 plus negative 5 times 10, oops, minus 1, right? 1 plus negative 5, and this is 9, so negative 5 times 9, which is negative 45. Okay, so 1 plus negative 45 is negative 44. That's your answer. Alright, so here we have question 23, and it says if x star y is equal to x plus y squared, find the value of parentheses 2 star 3 star 5. Now there's one thing I want to point out before we even get started, and that is this symbol, that this right here. This is not a multiplication sign, so don't get confused by that. What they mean is they're kind of coming up with an operation here, and this, I mean, I think it looks like a star, so that's why I'm calling it a star. I can't quite tell because the type is so small. But essentially, what this symbol means is that you're going to do this operation with it. Okay, so here we have 2, and I mean, I'm actually just going to draw a star because that's really what I see it as. Okay, so here we have this operation. Okay, so what do we do with it? Well, we just follow what it says for us to do. So we're going to do what's inside the parentheses first, because that's, you know, the order of operations. Parentheses first. Okay, so this is 2 star 3. So in this order, because that's how we found it in. So this will be our x, and this will be our y, and we're just going to treat it exactly how it tells us to. So 2 plus 3 squared. So then we're going to get 2 plus 9, which is 11. And now, but we have, this was 11 inside of parentheses. Now we need to do 11 star 5. So what do we do with that? The same exact thing that we just did. We have to do 11 plus 5 squared. So it would be 11 plus 25, and when you add that up, you get 36, which is the answer right here. So here we have question 24, and it says if p and q are two non-zero numbers, and 18 times the quantity p plus q is equal to the quantity 18 plus p times q, which of the following must be true? And then it gives us some options. So I've gone ahead and I've written out what the question gave us. So it told us this much, so I wrote it out. And now I'm going to start simplifying to see what I can find as it could be true of p and q here. So I'm going to distribute the 18 over here. So 18p plus 18q is equal to, and now I'll distribute the q over here, 18q plus pq. Okay, so just looking at this, right now I see that I have 18q on this side and 18q on this side. When you're working with an equation like this, and you see that you have two terms that are exactly alike on both sides, and they're alike in sign, which means they're both positive or they're both negative, you can cross them out. And so the way I know that is, I would say, let's say I wanted to simplify, I would say, oh, subtract 18q, subtract 18q, and now it's gone from both sides. And so you can speed the process up for yourself if you just realize now that if you have the same exact quantity on both sides and they're both the same sign, you can just cancel them out. Okay, so what do we have left right now? We have 18p is equal to pq. Okay. Well, here's the we have p here and p here. So what I would divide by p, and that goes away too. So now I have 18 is equal to q. Okay, so and that's one of our options. Q is equal to 18. So here we have question 25, and it says if and it gives us a matrix where it shows x, 2, 3, and 7. And it says that it's equal to 15. So when you have a matrix like this and you're not combining it with any other matrices, it's actually fairly simple to work with. What you want to do is first multiply this diagonal, so this is going to be 7x, and then you're going to subtract the other diagonal, minus 6, and you just set it equal to 15. So now we're just going to solve for x. So 7x is equal to 15 plus 6, which will be 21. And then we divide by 7 to solve for x, and x is equal to 3. So here we have question 26, and it wants us to evaluate, and it gives us a matrix with 3 rows and 3 columns. And so what we want to do here is, and you'll see I've split it up into certain colors, and so I'm going to try to make use of that in explaining, so hopefully, whoop, that's not the color that I wanted. Okay, hopefully this will make some sense. Okay, so here, I'll rewrite it actually for right now. 2, 0, 5, 4, 6, 3, 8, 9, and 1. Alright? The top row here are going to be what we're going to use to section off the rest of this matrix. Okay? So let's focus on the 2 first. Okay? It's going to be 2 times, and we're going to make a smaller matrix to work with. So it's going to be 2 times, and I've written here step 1 is this light blue color. It's this corner, 6, 9, 3, 1. Okay, and then it's going to be, moving on to the next color, then we're going to use a 0. Okay, so it's 0 times, and then it's going to be the outer edges. So it's going to be 4, 8, 3, 1. Okay, and then lastly, it's going to be this right here. We're going to use the 5 now, and it's going to be this corner over here this time. So 4, 8, 6, 9. Okay, and now that we've gotten this far, we can work with the matrices a little bit more easily. So here we have this, and so basically what it's going to turn out to is it's going to be 2 times, and remember we multiply diagonally first here, and then the second time we subtract. So 9 times 3 is 27. Okay, over here we just have the number 0. 0 times, no matter what this is on the inside, is just 0. And then we have 5 times, and then here we're going to do 4 times 9, which is 36, minus 6 times 8, which is 48. Okay, and now we just start simplifying. So this is going to be 2 times negative 21, okay, plus 0, so I'm just going to leave that out, plus, it's going to be 5 times 36 minus 48, which would be, I want to say negative 12, but I'm going to check my math real quick before I make any mistakes. Okay, but it's 36 minus 48, so it'd be negative 12. Okay, good, negative 12. And then, I just continue simplifying. So, this is going to be negative 42 plus negative 60. And we're going to get negative 102. And so, I didn't manage to put in the options for the answers this time, but this is your answer. Okay, so here we have question 27, and it's a matrix, and it says if P is equal to, Mr. A, so P is equal to the matrix where it's 2, 1, negative 3, 1, and they want to know what is P inverse. Okay, so the way that we're going to go about solving this is using this that I've written out over here. And I'll explain to you what this is. Okay, so here I have basically the skeleton or the structure of the matrix, right? We have 4 numbers in there, A, B, C, and D, and we want to find the inverse. So what we're going to do to get there is Well, first off, we have to find the determinant, okay? And so the determinant is basically what we've done in the past is when I don't know if it's asked us to solve what is this matrix. It's asking us to solve for the determinant. And so the way that we get that is we multiply A times D, so it'll be A, D, and then we subtract B times C. Okay, so this will be our determinant, but if you'll notice, I wrote 1 over the determinant. So when we start finding the inverse or the reciprocal of it, it's going to be 1 over all of this. And then it's going to be times, and you'll notice the letters are out of order. So what happens is the D and the A switch. A was here, D was here, but now it's the other way around. And the C and the B stay in the same spot, but their signs change. Okay, so now this is negative C and this is negative B. Okay, so let's put what we just learned to use over here. And I just want to mention that the reason why there is this notation, why are we finding the inverse of a matrix in the first place? What's the point? Well, the idea is that you cannot do division with matrices. There is no operation for it, but you can use the inverse of it to sort of substitute for division. And so what I mean by that is, so let's say that you cannot do division, but someone asks you, well, okay, so someone says, I have 10 apples, and there's 5 people. How do I share my apples? What am I gonna do? Okay, so what you would say normally is you would say, well, just do 10 divided by 5. Everyone gets 2 apples. But if you can't do that, you would need a certain inverse to get there. So you'd have to do 1 over. Let me think here. It would have to be 1 over. It'd be the reciprocal of 5. So I know it's like saying 1 over 5, but you really have to think of the reciprocal of it or the inverse of it. And so 1 over 5 is 0.2. And so you could do 10 times 0.2. And so here technically we've avoided doing division by finding the 5 to the negative 1. And so that's kind of what they're doing with the matrices here, because inverse matrices have the same properties as reciprocals do. So if I take 8 and I say, what's 8's reciprocal? Well, that's 1 over 8. What happens when I multiply these two numbers? I get 1, right? Well, the same thing happens if sort of the same thing happens. If I have this, let's say this letter represents a matrix, and I'm multiplying it by its inverse matrix, I will get the identity matrix, which will look like it'll be a perfect square. So what I mean by that is it'll be a square, so it'll have 2 rows and 2 columns, 3 rows and 3 columns, 4 rows and 4 columns, so on and so forth. And it'll always have ones going down the diagonal, and everything else will be a 0. So let me show you. This would be for 2. This is an identity matrix for 2. Okay. This is an identity matrix that has 3 across and 3 down. Okay, and basically the idea is it goes 1 all down the diagonal and everything else is zeros. And so these two are kind of synonymous to each other. They relate to each other. And so yeah, the whole idea is you can't do division with matrices, so that's why we look for the inverses. So let's get back to solving the problem with what we had learned over here, okay? We have our starting point. This is our matrix that we're starting with right here. This is A, B, C, and D. So let's convert it into this so we can start getting an answer. So first let's find our determinant. So to find the determinant, remember I said A times D minus B times C. So I'm going to do that over here. 2 times 1 is 2 minus 1 times negative 3 is -3. So I'm going to put parentheses, the -3, okay? So this will give us our determinant, and so this is the same as saying 2 plus 3, which is 5. Okay, so this is our determinant. I think it's ENT, determinant. Okay, so that's that. But remember that we're going to take 1 over the determinant and then multiply by the matrix, this new matrix over here. So far we have 1/5, and then let's set up the new matrix that we're going to need. So D and A switch places, okay? So here I had 2 here and 1 here. Now I'm going to put 1 here and 2 here. Alright? And then C and B stay in the same spot, but I changed their signs. So 1 becomes -1, -3 becomes +3. And now I'm really close to finishing up. I just have to multiply this. And since it's just 1/5 outside of the matrix, I can just say 1/5 times each one of these numbers, and that'll give me my new answer. It's like multiplying by a scalar. There's no special trick to it. You just multiply everything by 1/5. Okay, so my new matrix will be 1/5, -1/5, 3/5, and 2/5. Okay, and that would be my answer, which I think was this one. Alright, so here we have question 28, and it gives us this diagram, and it tells us from the diagram above, find x. And so I know the picture is pretty small on here right now, but just bear with me. There's really only 2 really important things that you need to notice before you can start solving this problem. And so I'll start by drawing just a simple circle. Okay, and then so I want you to notice right now that, and let me draw a quick line going through it. Okay, if I have 2 lines meeting at any point along this edge of the circle, those 2 lines will form a 90-degree angle. Okay, and so I'll show you down here. I had pasted this giant picture of a protractor, and so basically what I'm going to do for you is I'm just going to show you that there's no exact reason why I chose a protractor. It's just an object that's a good semicircle. And so I draw to one edge of the semicircle, and this sorry. See if I can. Oh, there we go. Okay, let's just pretend that's from the bottom right now. Okay, so I draw out to the edge of the semicircle, and I do it also from the other side. Okay. This is really a 90-degree angle, and it'll work that way. If I had a slider option and I told you to click on this dot and move it, drag it here, drag it over there, no matter what you did, that angle would stay 90 degrees. So the point I'm trying to make for you is that if you have 2 lines coming out from the edge of the circle, and it's meeting over here on this edge, if it's in a semicircle, it's going to be 90 degrees. Okay, so that means that this angle right here is 90 degrees, and they just told us that this one is 25. They have it labeled for us right here. This is 25 degrees. Okay, so there's this other piece of information right here. We have this line, the TU segment, and so I'm going to try my best to make this line tangent to my circle. Okay, so I realize that's probably not the best representation because it makes it look like my lines are parallel. I'll put it up here. Okay, so here we have line TU, and I guess these 2 lines would come out and they'd meet over here, but that's not actually that important. The point that I'm trying to make here is that x that they want is involving right here. And I guess, well, technically this meets up here. It meets up with line TU, okay? Right there. And so as it turns out is that because TU is tangent to this circle, this angle is also x. These two angles are exactly the same. And so this is really lucky for us because that means that we can just go ahead and set up a really simple equation where I say 25 plus 90 plus x is going to equal 180, because that's how many degrees there are in a triangle. And then we can just solve for x and that'll give us our answer. Okay, so let's go ahead and let's keep going. So 90 plus 25 will give us 115, and then so plus x is equal to 180, and I'm going to subtract 115. So then x is equal to, and let's see here, like this, and so there we go, x is equal to 65 degrees, which is your option right here. Alright, so here we have question 29, and it says the interior angles of a quadrilateral are x plus 15 to the, x plus 15 degrees, x plus 15 degrees, 2x minus 45 degrees, x minus 30 degrees, and x plus 10 degrees. And it wants us to find the value of the least interior angle. Alright, so to be able to do this, the first thing that we want to do is ask ourselves, how can we find x? Because we're going to need to find an exact value. So we need to find something that we can make x be. And so we'll notice that they said a quadrilateral. Quadrilaterals have interior angles that add up to 360 degrees. So that means that we can take x plus 15 plus 2x minus 45 plus x minus 30 plus x plus 10, and we can just set this equal to 360. And when we solve for x, that can help us to get closer to our answer. So, okay, so let's start combining like terms. Here's an x, 2x, another x, and another x. So, let's count up how many we have. 1, 2, 3, 4, 5x. Okay, so here we have 5x. And now let's add everything else up. 15 and negative 45, negative 30, and 10. Okay, so I'm going to do some scratch work on the side. 15 and negative 45, negative 30, and 10. So what I'm going to say is I'm going to make these two combine, and it'll be negative 30. And these two combine, and this will just be negative 20. And then, so this makes negative 50. So 5x minus 50 is equal to 360. And then I will divide, let's see if I can get this to go away. Okay, I will add 50 to both sides. So now I have that 5x is equal to 410. I divide by 5. And I get, divide by 5. So 8, this will be 40, and this will be 2. So I get that x is equal to 82, and remember we're working in degrees here, 82 degrees. Okay, so now it wants me to find the least value of x. So this takes a little bit of intuition, but it's not that bad. So which one of these will, not the least value of x, which one of these will give me the least value of an interior angle? Okay, so here we have 82. Imagine that I plugged 82 into all of these. I can see right away that adding to it is going to make it bigger, and I want the smallest value, so that's not going to be a good option. The same thing happens over here, so it's also not going to be a good option. Say I multiplied 82 by 2 and then subtracted 45. And then compare that to what if I took 82 minus 30. This number is going to be bigger than that, so I'm also not going to pay attention to this. So this will give me my least interior angle. So now I have to plug in 82 so that I can get the actual value of it. So I'm going to do 82 minus 30, and that'll give me 52, which is an option right here. Okay, so here's this question, it's number 30, and it says from the cyclic quadrilateral TUVW above, find the value of x. And so basically what you really need to know for this question is this theorem. It says the sum of the opposite angles of a cyclic quadrilateral is 180 degrees. There is a whole proof that you can do to to prove this to yourself, and you can look it up and check it out, or you can just take my word for it for now, and then just remember it and hold it inside yourself. Okay, so the sum of opposite angles of a cyclic quadrilateral is 180 degrees. So these two are opposite angles of a cyclic quadrilateral. So their sum is going to be 180 degrees. So here we have 88 plus 3x plus 20, and we set it equal to 180 degrees. Okay. I leave out the degrees symbols while I'm working out the math because I don't want to confuse myself thinking that I'm saying to the 0th power or something. So I tend to leave them out until I reach my answer. But anyway, so here we have 3x plus 88 plus 20, and it's been a long day, so I will do the math for it. Okay, there we go. 108 is equal to 180. So then we're going to subtract 108. I'm going to get 3x is equal to 72. That's this. Okay. So 3x is equal to 72, and so we're just going to divide 72 by 3, and we're going to get 24. So x is equal to 24 degrees. So here we have question 31, and it says if the two smaller sides of a right-angled triangle are 4 and 5 centimeters, find its area. And I'll go ahead and use lines so that it would be a little bit easier to see instead of my squiggly hand drawing. Okay, so when they say the two smaller sides, they mean the sides that aren't the hypotenuse. So this would be the 4 centimeters, let's say. This would be the 5 centimeters. And you don't even need to try to find the hypotenuse of this right triangle. All you need to know is this and this, because remember that the area of the triangle can be found by taking 1/2 times the base times the height. But we have the base here and the height here, so we're just going to do 1/2 times 4 times 5. So that's 1/2 of 20, which will give us 10. So 10 centimeters squared is our answer. Alright, so here we have question 32, and it says an arc subtends an angle of 50 degrees at the center of a circle of radius 6 centimeters. Calculate the area of the sector formed. And so I've written out here a few equations that will be helpful in figuring out what exactly is the area of the sector formed. So first off, we should know that to get the area of a circle, we use the equation pi r squared. And so that'll help us out down here, because in order to get the area of the sector, we need to know the area of the circle as well. And we do that so we can find the ratio, and once we know the ratio of this, we can set it equal to the ratio of the degrees of that sector over the degrees of the circle. And so what I'm going to do then is I'm going to start setting things up. So let's find the area of the circle. So it's pi r squared. Well, they gave us r. The radius is 6 centimeters. So it's going to be pi times 6 squared. However, they were helpful enough to give us a fractional form of expressing pi. So we're going to be using, instead, we're going to be using 22 over 7. And so we'll leave this as is for now. I'm not going to do much simplifying with that at the moment. So the area of our sector, I'll call it A, is going to be equal to the area of, over the area of our circle, which will be 22 over 7 times 6 times 6 again, is going to be equal to the degrees of the sector, which they told us were 50, over the degrees of the entire circle. And so the entire circle is 360, and we know that because there's 360 degrees in a circle. So now I'll start getting around to simplifying. 50 over 360, we can cancel out the zeros and say this is like 5 over 36. And so then I'm also going to multiply both sides of the equation by this. And so that way I can start solving for what the area of the sector is. So I'm going to set this equal to 5 over 36 times 22 over 7 times 6 and times 6 again. So I could express this to make, if you can't see it yet, this is like saying 5 times 22 times 6 times 6 over 36 times 7. So now I can do some simplification. 6 times 6 is 36. So that means I can cancel these two, this out and these terms out as well. So now I'm left with 5 times 22 over 7. Okay, so and if you'll notice, the answers that they give us are all over 7. So I'm not going to have to simplify that far down. Let's just figure out what 5 times 22 is right now. So 5 times 22, and so this should be 10, and then there we go. So it's 110, 10 over 7, and that's the area of our sector. Alright, so here we have question 33, and it says a cylinder pipe 50 meters long with radius 7 meters has one end open. What is the total surface area of the pipe? So I've started by writing out the equation for the surface area of a cylinder, and I've labeled its two main parts. So here we have 2 pi rh plus 2 pi r squared. The first part, 2 pi rh, will give us the surface area of the side. That's this part, the long end, or the long pole part of the cylinder. 2 pi r squared gives us up here and down here. That's the top and the bottom of the cylinder. And so when we add up all of those areas, the side, the top, and the bottom, that gives us the total surface area of the cylinder. The thing that's different about this question is that they're not just asking us about the total surface area of the cylinder. They're telling us that it has one end open. So all we have to do is not account for one of these ends. So instead of saying 2 pi r, we're just going to say, instead of saying 2 pi r squared, we're just going to say pi r squared. Because the reason why it's 2 pi r squared is because just one of these, the top or the bottom, the area is pi r squared. That's why we have 2 pi r squared, because there's two of them. So one of them isn't there, so we won't have to count it. So this time, the area for this specific cylinder that has one end open is going to be 2 pi r h plus pi r squared. Alright, and they already gave us our radius, that's 7 meters, and our height is 50 meters. So we can just go ahead and plug these two values in, and we'll get our answer. So 2 pi times the radius, which is 7, times the height, which is 50, plus pi times, again, the radius is 7 squared, okay? Let's keep going. Sorry, I was not very neat with my handwriting here. So there, it's 2 times pi times 7 times 50, okay? So let's say 2 times, well actually I'm going to say 2 times 50 first, because that's easier, that's 100. And then times 7 is 700, so here we have 700 pi plus, and then 7 squared is 49, so this is 49 pi. Because these are like terms, they both include pi in them, we can just go ahead and add this up. So this is 749 pi, and don't forget your units, it's meters squared, and that's our answer right there. Question 34 asks, what is the locus of points that is equidistant from points P1, 3 and Q3, 5? So I've drawn us a diagram to help understand what it is that they're asking about. And I've also given the formal definition of what it is that they're asking about as well. So the locus of points equidistant from 2 points P and Q is the perpendicular bisector of the line segment determined by the 2 points. And so what that means is, at first it seems that there's only going to be one point between these two where it's always going to be equidistant. But actually there's many. So at first you might look at this, and let me find a different color. At first you might look at this and think that this is the only point that's going to make sense for what they're asking for. This is clearly equidistant from P and Q. But actually I could also put a point here. Sorry, I could put a point here, or here, or here, or here. And the idea is that any one of these points is technically speaking equidistant from P and Q. And what I mean is, if I go out from here to here, or from here to here, those two lines are exactly the same length. And the same goes if I go from here to here, and here to here, and so on and so forth. All of these end up being so that they're equidistant from P and Q. So what is the equation of this line? Well, actually it's fairly simple to deduce the line just by looking at this graph, and I'll teach you how to do that. Or you can also use an equation, and I'll show you it doing that way as well. Okay, so let's just look at this line that we've come up with, that we've deduced just by looking what it would be. So remember that let's remember the equation of a line first. It's y equals mx plus b. Okay, what is m? M is our slope. This is clearly a line that is going in the negative direction. Okay, so this is going to be a negative slope. So y equals negative x, and then what's b? B is our y-intercept. Where does it hit on the y-axis? Well, let's see. Here's the y-axis, and it's hitting right here at one point above where Q is. This scale is drawn to a 1-to-1 scale, so here's 1, 2, 3, 4, 5, 6. It's hitting at 6, so plus 6. And actually this would be your answer. And so that's a fairly quick and easy way to solve the problem, but sometimes it's not so straightforward. Sometimes you can't just figure it out right away by looking at it. And so there's also an equation that we can use to solve for this. And so what you would do is you would say x minus x1 squared plus y minus y1 squared is equal to x minus x2 squared plus y minus y2 also squared. And so now we're going to plug in the 2 points that we have. So remember we have P, which is equal to 1, 3, and Q, which is equal to 3, 5. This is going to be our x1, y1, and this is going to be our x2, y2. So let's go ahead and start plugging in, and then we'll solve for we'll solve for the line that is equidistant from these 2 points. Okay, so here we have x minus 1 squared plus y minus 3 squared equal to x minus 3 squared times y minus 5 squared. Okay, let's expand and start simplifying. So x minus 1 squared. And so there's a pattern that will happen when you multiply two. Well, here I'll show you. So x minus 1 times x minus 1, we would get x squared. This would be minus x, and this would be minus x again. And we'd have plus 1. So the general pattern that you're going to see here is it's going to be x squared minus 2x plus 1. So what I did was this squared, and at the end, this squared. And in the middle, you're going to have negative, sort of double the negative of these two multiplied. Okay? So you'll see the pattern as we keep going. So this is going to be y squared minus 6y plus 9. So like I said, the first term is y squared, the last term is negative 3 squared, and then the middle term, what I did was I said negative 3 times y times 2. Okay? Keep going. So x squared minus 6x plus 9. Okay, and then one more. Sorry, I forgot to put a plus sign here. One more, this is going to be y squared minus 10y plus 25. Okay, now let's combine like terms and cancel where we can. So the first thing I'm noticing here is we have an x squared, a y squared, and a y squared. Since these terms are the same and they're in the same sign, so this x squared and this x squared are both positive, but they're on opposite sides of the equation, I can just go ahead and cross them out. And you know, you would see that you would say minus x squared and minus x squared, and they would both be gone. So why even bother if you just recognize it and get rid of it right away? Same thing with this y squared over here. Okay, so those two are dealt with. So now let's keep going. So here we have negative 2x, and there's no more x on this side, so it's just going to be negative 2x plus 1 and 9 makes 10 minus 6y. And then on this other side over here, we're also going to have minus 6x and plus 34 minus 10y. Let's keep going, or I'm going to say plus 2x plus 2x. Here we're going to have 10 minus 6y is equal to negative 4x plus 34 minus 10y. I'm going to add 10y to both sides. And so if it's not clear to you what it is exactly that I'm trying to do here, I'm trying to get y on one side of the equation by itself so that I can get it into that point, into the y equals mx plus b form that we're so used to seeing. And so now I'm going to subtract 10. So here we have negative 4y equal to negative 4x plus 24. Now we divide by negative 4. So y is equal to negative 4, and divided by negative 4 is just is just 1. And I think I made a mistake in my math somewhere along the way. So let me look back. And so the way I'm realizing this is that up here, we saw that our slope is clearly going to be negative. So this should be a negative value of x. And, well, let's see what happened. Right here. Negative 6x plus positive 10y should be positive 4. Okay, so then divide by positive 4. Okay, so here we have negative x. And then 24 divided by 4 is plus 6. So y is equal to negative x plus 6, which is the same thing that we got when we worked it out by looking at where the y-intercept was and what the slope is. I also want to point out, I don't think I mentioned this the last time, I said that it's clearly a negative slope. It is, and it's also clearly a negative slope with a value of 1. So it could have been negative 2x or negative 3x, and the way I knew it was negative 1x is because it goes down 1, over 1, down 1, over 1 each time, right? So there's two methods for solving this problem. Both lead you to the right answer. Sometimes this one will be easier, but sometimes you won't have the option of being able to draw out the graph and look at it. Sometimes the points might be really, I don't know, far apart, or it might not, it's just not going to be as simple, so you can use this equation as well. Okay, so here we have question 35, and it says find the distance between the points 1/2, 1/2, and negative 1/2, negative 1/2. So I've written out the distance formula, and it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And so here we're just going to, I'll show you where the x2 and the x1 and the y2 and the y1 come from. So we have the point 1/2, 1/2, and negative 1/2, negative 1/2. So this is going to be our x1, this will be our y1, this is our x2, and this is our y2. That's funky looking too. Okay, so let's plug these into our formula. So x2, I said is going to be, you know what, actually I'm going to reassign these to make the math a little bit easier. I'm going to make this, they won't delete. There we go. Okay, I'm going to make these ones up here my x2 and y2, and this one up here, actually I think it was fine just the way I had it. So essentially what I'm trying to do here is I'm going to set it up so that when I subtract over here, like it says I need to, I'm going to subtract the negative number so that it becomes adding, and that way I don't have to worry. I don't have to worry about my negatives anymore. It just becomes much more easier that way. And as long as the x's are put together and the y's are put together in the same order, everything should turn out fine. So here I'm going to take 1/2 minus negative 1/2 squared plus, plus 1/2 minus negative 1/2 squared, and there we go, like that. And so see, you'll see here what it was that I was trying to tell you. Here's two negatives, and so that makes our case a positive. So 1/2 plus 1/2 squared plus 1/2, and the same thing happens here, squared. And so now we have, well, 1/2 plus 1/2 is just 1. And that's squared plus, again, 1/2 plus 1/2 is 1 squared. So now we have the square root of 2. And so that would be our answer. So here's question 36. It says find the gradient of the line passing through the points P1, 1 and Q2, 5. So Remember that to find the slope, we can do it very quickly and easily by using this formula. And what it comes from is but when we have a coordinate plane, and let's say we have a line, the slope or the gradient is the rise over the run. So rise over run. And so the rise is represented by the y values, and the run is represented by the x values. So rise over, literally over the run. So just remember to keep track of which ones you use where. So what I mean by that is here we have the point 1, comma 1 and 2, comma 5. So the way I'm going to do it is, well, I'm going to take my y's, I'm going to say 5 minus 1 over, and then when I choose which x to use first, I make sure that I use the same ordered pair that I used first last time. So since I used 5 first, I have to use its partner for the ordered pair first as well over here to make the math work out right. 5 minus 1 is 4. 2 minus 1 is 1. So this gradient is 4. Question 37 says, find the equation of a line parallel to y equals negative 4x plus 2 passing through 2, comma 3. So what we're going to do here is first identify what is the gradient or the slope. Well, that's negative 4. Okay, and then we're going to use the equation that we would use to find that gradient or that slope. So remember that it's rise over the run, so y2 minus y1 over x2 minus x1, and that's going to be equal to our gradient. So using what we just said, we know that 2 and 3 have to be in 2, comma 3 has to be included in this line, and we also know, well, what the gradient is, and so we can actually work our way backwards with what we have to get back to what our line would be. And so I'll show you what I mean by that. So we don't know this y or this x, but we do know that this is 3 and that this is 2. And we know that our gradient is negative 4. We have everything we need right here to get us back to the equation of a line. And so what I'm going to do is I'm just going to first off multiply everything by x minus 2 so that they cancel on this side, and I'm left with y minus 3 is equal to, and I'll distribute my negative 4, negative 4x plus 8. And then you'll notice over here that they want it in the form where it's set equal to 0. So I'll go ahead and subtract 8. So y minus 11 is equal to negative 4x. And then I'll add 4x. So y, this is y minus 11 plus 4x is equal to 0. And that's our answer. And that is our option D. Question 38 says, if cotangent theta equals 8 over 15, where theta is acute, find sine theta. So I've written out a few things that we should take into account before we go on to answering the question. So this is talking about cotangent. Remember that cotangent of theta is the same as saying 1 over tangent theta, which is the same as saying cosine theta over sine theta. Alright? So this is cosine theta over sine theta is what they're giving us. And they told us that it's 8 over 15. Now, let's take a look at what cosine and sine specifically mean. So cosine, I've written out here SOHCAHTOA, so maybe you've heard of this. It's just a system used to help you remember what goes with what. So cosine is the same as saying the adjacent over the hypotenuse. So what do I mean by adjacent and hypotenuse? Okay, well, you probably know what hypotenuse is. It's the hypotenuse of the triangle. And when I say adjacent, I'm talking about the angle that is adjacent or next to I'm talking about the side that is adjacent or next to the angle of interest. So here's our angle of interest, theta. The side that's right next to it is this one right here. So this is the adjacent. This is the hypotenuse. And over here will be the opposite. This is the side that is opposite the angle of interest. So cosine is adjacent over hypotenuse. So I wrote that out here. Adjacent over hypotenuse. And then, so I'm going to erase this real quick so you can see it step by step. So it's adjacent over hypotenuse. And then, remember that we're doing cosine over the sine of theta. So what is sine theta? Sine theta is the opposite over the hypotenuse, divided by opposite over the hypotenuse. Well, there's a simpler way of dealing with dividing fractions, and that's where you multiply by the reciprocal. So we're going to say times the hypotenuse over the opposite. Now, if you'll notice, the hypotenuses will cancel, and we're just left with adjacent over opposite. And they told us that the cotangent was 8 over 15. So that means that our adjacent is 8 and our opposite is 15. So now I can replace this. This is 8. This is 15. Now we can solve for the hypotenuse so that we can find what they ask us, sine theta. So remember that sine is the opposite over the hypotenuse. We already have the opposite. Now we need to solve for the hypotenuse, and then that'll give us our answer. So you may know, because there's sets of three numbers that you can find where they all work together. So what I've been saying by that is you can have like 3, 4, and 5, where this could be 3, this could be 4, and this would be 5. And basically, it's 3 squared plus 4 squared equals 5 squared. And so certain numbers come in sets of 3 that will satisfy a right triangle. And so 8, 15, and 17 happens to be one of those numbers, one of those sets. However, if you don't know that, that's okay. You can just solve for it by doing the square root of 8 squared plus 15 squared. Because remember that the hypotenuse is equal to a squared plus b squared. Sorry, the hypotenuse squared, or sometimes it's referred to as just c squared. So c squared is equal to a squared plus b squared, where c is the hypotenuse. So when we take the square root of everything, we should get c, or the hypotenuse. So I'm going to have to do the square root of 64 plus, and I don't remember off the top of my head what 15 squared is, so I'm just going to have to do the math. This is 25, this is 7, that's 5, 1, add 5, 7 plus 5 is 12, 1, 2, okay, plus 2, 25. Now I'm going to line them up so I can make sure that I add these right. 9, 8, 2, so the square root of 289, which hopefully you know is 17. So our answer, remember what they're asking us for the sine theta, so our answer is the opposite, which is right here, 15, over the hypotenuse, which we said was 17. So 15 over 17 is right here. Okay, so question 39 says, if the area of triangle PQR above is 12 root 3 centimeters squared, find the value of Q. So I've written out here an equation for the area of a triangle that you may or may not be used to, and it says area is equal to 1/2 times A times B times the sine of theta. And I've written here that the theta you use should be included between the two sides you chose. So where does this come from? Maybe you're only used to seeing that area is equal to 1/2 times the base times the height. Well, this equation is actually the same thing as this one. It's just that we've replaced height with something else. See, the thing is, this equation is easy to use when you have a right triangle and it's easy to see where the height is or how much the height is. But when you have a triangle that's not necessarily a right triangle, well, then it's a little bit different to find the height. And so I'll show you where it comes from. So say I made a right triangle out of this, and So here's a right triangle, and let's say that I have sides A, B, and C, and these are my angles. Okay. Alright, so the sine of theta. Let me show you what I mean by that. So let's say I chose one of these to be my theta. I'll choose this one to be my theta. So what is the sine of this theta in terms of just this triangle? Well, okay, so remember from SOHCAHTOA that sine is opposite over the hypotenuse. So opposite of this angle will be this, which we can tell is the height, right? And the hypotenuse for this triangle and this angle is over here is B. So I'm going to say that the sine theta of, well, it's the sine of A, I can call it. This is angle A, let's say, is equal to the opposite, which we said was the height, over B over here, which is in our case the hypotenuse. Okay, so what is it saying? So this is the height, this is the hypotenuse, or just the side length over here, B. And so what if I solved for h? Well, h would be equal to the sine of that angle A times B. This is this. Do you see that? The sine theta, or the sine of an angle, times B is equal to the height. This is where this came from. Okay, and then A is the other. You have to choose. And see, the thing is that it could be over here too, and so sometimes it'll say A, B, sine C, or and then it'll switch it up and say B, C, sine A. What they want you to know is it has to be, the angle that you choose should be between the two sides that you want to use. So in our case, let me erase all of this. In our case, they give us a triangle and it looks like this. And so the angle that we want to use, we don't need all this right now. Let's see if I can select this one. Okay, the angle that we want to use is this one up here, and it's 60 degrees. So that means that we want to use this side and this side. And here's 8 centimeters and here's Q. So that's what we need to solve for. So, okay, so this is 8. This over here is Q. And now we can use this formula to solve for what we need. So they tell us that the area is 12 root 3 centimeters squared. So here is 12 root 3 is equal to 1/2. Let's see if it'll scroll down for me. 1/2 times the two sides. So it'll be times 8 times Q times the sine of the angle that is between them, times sine of 60 degrees. Okay, and then I have pasted here from Wikipedia, the free encyclopedia, a image of the unit circle to point out to you what it is I'm trying to say here. The sine of 60 degrees, remember these come in pairs of cosine then sine, so the sine of 60 degrees is root 3 over 2. So here we have 12 root 3 is equal to 1/2 times 8 times Q times square root of 3 over 2. So now we can start simplifying. 8 divided by 2 is 4. 4 divided by 2 is 2. So here we have 12 root 3 is equal to 2 times Q times the square root of 3. So now we can cancel the root 3's, because divided by square root of 3 on both sides, and these will cancel. So that 12 is equal to 2 times Q. Then we divide by 2 on both sides, and we get that q is equal to 6, which is our answer right there. So here's question 40, and it says if y is equal to the quantity 2x plus 1 cubed, find dy dx. So I've written out here what it is that they want us to do, and I've written out a very important thing that we need to note before we get into this problem, and it's the chain rule, which states that if we're going to take the derivative of functions that are composed with each other, then we have to follow this rule, which says that we have to take the derivative of the outer function and evaluate at the inner function, and then multiply that by the derivative of the inner function. So what do I mean by that? Okay, let's look at this and let's find an outer function and an inner function. What do I mean by that? So I'm going to say that my outer function f of x is x cubed. So why did I say that? Well, what's the last thing that we did to this equation over here? We took something, a quantity, and cubed it. So that's my outside function. My inside function, g of x, is 2x plus 1. Okay, so now that I have this, I can use this form to help me get to my answer. So what I said, take the derivative of the outside function and evaluate at the inside function. So what do I mean by that? So what is the derivative of f of x? Of this. What is the derivative of this? Well, that would be 3x squared, right? This is our derivative. So what I'm going to say is 3 times x squared. But what is x? Well, I said to evaluate it at the inner function. So my x here is 2x plus 1. That's the inner function. So this is 2x plus 1. And then I have to multiply it by the inner function. So times, what's the inner function? Well, and I'm going to use my dot symbol to mean times because there's a variable x here. That could get confusing. So times, let's take the derivative of 2x plus 1. Well, we know that the plus 1 is just going to turn into 0, and the derivative of 2x is just 2. So that's the derivative of g of x. So I multiply by 2. Now I have 6 times 2x plus 1 squared. And we can actually stop there because that's how they have their answer. That's the form that they have. So we don't have to expand or anything. We just have to find 6 times the quantity 2x plus 1 squared, which is right here. So here we have question 41, and it says if y is equal to x sine of x, find dy dx. So I've written over here what the product rule is, and it says that if we're going to take the derivative of two functions multiplied, then we have to use this rule to get our answer. So what you're going to do is first take the derivative of the first function times the second function left alone, plus the second function's derivative times the first function left alone. And so it's fairly simple pattern to follow once you get the hang of it. So here we have x sine of x. Okay, so let's split this up. So x sine of x is actually composed of two parts. Here we have x, and here we have sine of x. So what can we do with these two parts? We're going to split them up into f of x and g of x. So I'm going to say that x is our f of x, and sine of x is our g of x. And once you get better at this, you won't need to write it out the way I'm doing it right now. You'll be able to sort of just look at it and do it in your head. But I'm doing this for clarity so that you can see the process that I follow. So after this, where do we go? Okay, so now we're going to say take the derivative of the first one, or the one that we labeled f of x. So what is the derivative of x? Well, that's just 1. So the first part here is just going to be the number 1. And then it says to multiply that by the second part of whatever it is that you're working with. So the second part, the second function that we labeled was sine of x. And so we're just going to say times the sine of x. Then what do? We add this next part. So this time we're going to take the derivative of the second part, which was sine of x, which we got from over here. So what is the derivative of sine of x? Well, that's cosine of x. And then we have to multiply it by the first part left alone. So times x. So here we have x cosine x. If I rearrange this, this is the same as saying sine of x plus x cosine of x, which is the form that you will find it in up here. So here I have question 42, and it says, at what value of x does the function y equals -3 minus 2x plus x squared attain a minimum value? So the way that I'm going to go about solving this is I'm going to first take the derivative of the function that they give me. So here I have -3 minus 2x plus x squared. So when I'm taking the derivative, remember that d over dy dx. So when I'm taking the derivative, I can split this part, all of this up, or essentially derivatives are linear when it comes to addition and subtraction. So I can just go ahead and take the derivative of each one of these parts and then put them back together. So what's the derivative of -3? Well, that's going to be 0 because there's no change in slope because it's just a line. The derivative of -2x is -2. And remember that when we take the derivative of something with an exponent, it's going to be plus 2x here. We take this down and subtract 1 from here. So I put the 2 down, and then there's technically a 1 there, but you don't need to write it. It's understood. So here we have the derivative, and this will help us find the minimum value, because if we set this equal to 0 and solve for x, so I'll have -2 is equal to -2x. I just subtracted 2x on both sides there, and then I divide by -2 so that 1 is equal to x. Well, right here, this is my minimum. And so the way that this works is that when you take this function and you look at its derivative, and when the derivative is equal to 0, that'll give you a max or a min. So what do I mean by that? Let's just say that it looked something like this. Up here would be a maximum, and if it looked like this down here, somewhere around there, would be our minimum. And so what happens is that the slope of this line, of this curve, is changing. You know, it's going like this, and then like this, and like this, and like this, and over here it's doing the same thing. It's changing, but when it reaches that maximum or the minimum, it's not changing. It's not going, there's no change to the slope. It's 0. So if we set the derivative, which is what is essentially a measure of the slope, if we set the derivative equal to 0 and find out when that happens, then that can tell us when we have a max or a min for our equation. And so so then you know that the value that we are looking for is 1. Alright, so here we have question 43, and it wants us to evaluate the integral going from 0 to 2 of x cubed plus x squared. So the way that we're going to do that is, first we're going to take the antiderivative of what's inside here. So what I mean by that is we want to figure out what we started with to get to here. And so here we have x cubed. So let's start with just that part. So what could be the antiderivative of x cubed? So I know that if I take the derivative d dx of x to the fourth, I will end up with 4x to the third power. So these two are pretty close, except that here's this 4 that's different from over here. There's not a 4 there. But if I divide this by 4 and divide this by 4, then what I have is d over dx of x to the fourth over 4 is equal to x cubed. And that's what I wanted. I wanted to know what can I take the derivative of to get x cubed. So this part right here is what I'm interested in. And let's do the same thing for x squared. So again, I'm going to say d dx. And so I know that if I take x cubed, that I'll get 3x squared. And so again, I'm pretty close, but I have to divide by 3 on both sides. And then I have d over dx of x cubed over 3 is equal to x squared. And so again, I have what I wanted to know, which is the antiderivative of this. And so you'll see a pattern. It's fairly easy to spot. So here I had x cubed, and then I said x to the fourth over 4. And then here I had x squared, and then I said x to the third over 3. So I added 1 to get the exponent in the denominator. And you saw why it worked. And if you were to take the derivative of either of these, you would end up with what you started with. Okay? So now we have that part. Now we have to use the second fundamental theorem of calculus. And so essentially what that states is that to be able to evaluate this, we need to be able to take f of, I think it's usually denoted a minus f of b. So what does this mean? Big F in the second fundamental theorem of calculus is used to denote the antiderivative, which is what we found. And so, and the a and b, it's talking about an interval. So the original equation could have looked something like this, let's just say. And there was a point A on the x-axis and a point B again on the x-axis. And so there's all this area in between them, and that's the whole point of taking the integral, so we can find this. And so our a and b, well actually what's going to be is this is our starting point. This is going to be 2 and this is going to be 0. So let me switch this around if this matches what it's supposed to say. This and then this. And so basically you're going to take the antiderivative and then plug in the two values that they gave you, and you're going to subtract. You're going to have the end point and subtract the start point. Because if you think about it, you want the space in between here. It wouldn't make sense to take 0 and minus 2 because that would give you sort of like an inverse answer, which is not what you want. So we have here x to the fourth over 4 plus x to the third over 3, and we're evaluating it on the interval from 0 to 2. And so this notation, you'll see it used pretty often with these type of problems. And basically what it means is we're going to plug in 2 first, and then we're going to subtract what happens at 0. So, okay, let's evaluate it at 2. So 2 to the fourth power, I'm going to write that out as 2 times 2 times 2 times 2. And 4, I'm just going to write out as 2 times 2. And I'm going to say plus 2 to the third power, and I'm going to go ahead and evaluate that. So 2 times 2 is 4, times 2 is 8. So here we have plus 8/3. And then minus, evaluated at 0, or 0 to the fourth power is just 0, and divided by 4 is still 0, and the same thing happens over here, we just get 0. So now we just have to worry about this part. So these 2's will cancel, and these will cancel as well. So now I'm left with 2 times 2, which is 4, plus 8/3. And so what I'm going to do is I'm going to convert my 4 into something over 3. And so the way that I would do that is, remember that if I were to say 3 over 3, that would give me 1. This is 1 whole. What's 4 of these? Well, that's 12 divided by 3, right? Because 12 divided by 3 is 4. So now I'm going to say 12 divided by 3 plus 8 divided by 3. Since these have common denominators, I can now add them easily. This is 20 divided by 3, and then I'm going to simplify to make this a mixed number. So how many times does 3 go into the number of 20? Well, that's 16. Oh, sorry, just 6, which will give me 18. And I'll have a remainder of 2. And so some people might just write remainder 2, but remember that you can also say it as 6 and 2/3, because it's 2 over 3 left. So 6 and 2/3 is our answer. Question 44 says to find the integral of sine of x plus 2x dx. So what we have to do is basically, remember, it's like taking the antiderivative. So what did we have to take the derivative of to reach sine of x? Well, we know that that cosine, the derivative of cosine of x is negative sine of x. Yeah, all right. So the derivative of cosine of x is negative sine of x, but we want positive sine of x, so we would take the derivative of negative cosine of x in order to get positive sine of x. So there's part of it, the negative cosine of x, and then we have plus 2. So what do we have to take the derivative of to get to 2? So if I were to take, for instance, this example right here, x squared. If I were to take the derivative of x squared, I would get 2x. But that's not quite what we want. We just want 2. Well, what if I took the derivative of this, 2x? It would just be 2. So the starting point that I came from was this. This is 2x. And this was the other starting point. So it's negative cosine of x plus 2x. And there's one more part. You'll notice all of these have plus k. That's very necessary, because when you're taking the integral of something, there can always be another number added on to this, some sort of constant that could be pretty much anything, as long as it doesn't have a variable tagged onto it. So say the starting function had been negative cosine of x plus 2x plus 8. When I took the derivative of this, I would get sine of x plus 2, and that would be it, because this part, when you take the derivative of it, it would just be 0. And if this were 8, if this were 11, if it were 102, no matter what, that would always end up happening. But you always have to account for it when you take the integral. So that's why we include the plus k at the end. And so that's your answer. Question 45 gives us a chart, and it has marks and a number of students that achieve those marks. And then it says, from the table above, if the pass mark is 5, how many students failed the test? So the pass mark is 5, and they want to know how many failed. So if they achieved a 5, that means that they would be passing. So we don't include these students. Also, anything above a 5 would be passing. Anything below a 5, so if they achieve 2, 3, or 4, then they would be failing. So we just have to add up how many students got a 2 or 3 or 4. So it's 3 plus 1 plus 5, which is 9. Question 46 gives us a chart that's to be used for questions 46 and 47, and it says the table below, the table above shows the marks obtained in a given test. How many students took the test? And so we can see from the labels that the top numbers give us the marks, and the bottom numbers are the frequencies of each mark. So all we have to do is add up the frequencies to see how many students took the test altogether. Because by frequency they mean how many times each mark showed up. And so we're assuming that all of the marks are accounted for here. So if we add up the frequencies, then we should get how many students took the test. So 2 plus 2 plus 8 plus 4 plus 4. So this will be 4 plus 8 plus 4 plus 4. This will be 12 plus 4 plus 4 is 8. So 12 plus 8 is 20. So 20 students took the test altogether. Okay, so here we have question 47, and it also goes off the table that we used in 46. And so it says find the mean mark. And so you see that I've circled here the answer that we got for 46, which said how many students took the test. And that was 20. That's important for finding the mean, because to find the mean, not only do we need to add up what all of the marks were, but we have to divide by the number of occurrences. And so you'll see what I mean in a second. So here we have the marks, and okay, so the mark of 1 appeared 2 times. That's what the frequency means. So here we have 1 plus 1. The mark of 2 appeared 2 times as well. So plus 2 plus 2. Of 3 appeared 8 times. So plus 3 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 plus 3. I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. And then 4 appeared 4 times, plus 4, plus 4, plus 4, plus 4, and 5 appeared 4 times as well. Okay, so an easier way to add all of these up, instead of just trying to go straight down and add all of these numbers, is you can just multiply each mark by its frequency. So 1 times 2 is 2, and 2 times 2 is 4. 3 times 8 is 24, 4 times 4 is 16, and 5 times 4 is 20. Okay, and then, so we would add all of these up. So what do we get? We get 2 plus 4 is 6, plus 24 is 30, plus 16 is 46, plus 20 is 66. So the sum of all of the marks is 66. But now we have to divide by the number of appearances of each mark. And so the number of appearances of each mark, or the sum of all the appearances of each mark, I should say. So the sum of all of this, not necessarily of the numbers added, but how many numbers are here, is the same as saying how many students took the test. So what I mean by that is, if we were to count every number right here, we would find that the number is 20. So I'll go ahead and demonstrate. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there's 20 total marks. And so we have to take the sum of the marks, which we found was 66, and divide that by how many marks appear. And so you didn't have to go through and recount them, because if you figured it out in the previous answer, you could have just remembered, oh, it's 20. So you could have just been ready to go. So 66 divided by 20 does not go unevenly. So let's see. So this is 3 and this is 60. And then we'll have a remainder of 6. So 6/20. So we can simplify. And this can be divided by 2, so we get 3. And this will be 10. So 3 and 3/10, which is the same as saying 3.3. So our answer is right there. Question 48 says to find the standard deviation of 2, 3, 5, and 6. So in order to find the standard deviation, first we need to know the mean of these numbers. So we're going to add them up, 3 plus 5 plus 6, and we're going to get 2 plus 3 is 5, plus 5 is 10, plus 6 is 16, and then divide by the number of occurrences, which is 1, 2, 3, 4. So that's our mean. and then we're going to use the mean to figure out by how much did each of these numbers deviate from it. So essentially, what we're going to do is I'm going to say, for instance, 2 minus 4, which would give us negative 2, because that's how it deviates from the number 4. It's 2 less than 4. So that's where this comes from. But when we're taking the standard deviation, we want to square each one of these because we really don't want to deal with negative numbers. So then we're going to do the same thing for all of them. 3 minus 4 squared plus 5 minus 4 squared plus 6 minus 4 squared. So then 2 minus 4, like I said, was negative 2 squared plus negative 1 squared plus 1 squared plus 2 squared. So then we're going to have 4 plus 1 plus 1 plus 4, which is 10. Okay, so now to take the standard deviation, we have the deviation and we have the average. So to take the standard deviation, we need to take the square root of the deviation, the sum, over 4. And so remember we squared everything up here. So it seems appropriate that we should take the square root of things. And so now let's simplify as much as we can. So we can't really take the square root of 10 over 4 without getting some messed up decimal numbers. So let's just divide both of these by 2. So this will be 5 and this will be 2. So we're taking the square root of 5 halves. And that's your answer right here. So question 49 says, in how many ways can a committee of 2 women and 3 men be chosen from 6 men and 5 women? So essentially what we want to do here is we're going to use this right here. So in our case, order does not matter, but there cannot be repetition. And so what we're going to do is we're going to take the overall groups, the 6 men and the 5 women, and choose a certain amount from each. So for instance, they said a committee of 2 women from a possible 5. So it's going to be 5, choose 2. And then for the other one, it's 6 men total, and you are only choosing 3. So 6, choose 3. And so this is the formula that we use, and this is the way it's written out sometimes just to represent what we want to say. But when you get down to doing the math, you go and use this formula. So 5 is our n, so we're going to do 5 factorial over r factorial. 2 is our r. Make these exclamation points. Times 5 minus 2 factorial. And we do it again over here. So we're going to have 6 factorial over 3 factorial times 6 minus 3, the whole thing factorial. So, and then what do we do with these two? Do we add them? Do we multiply them? Well, we multiply them. And so it takes some thinking, but essentially the number of ways that you can make the committee ends up being the multiple of both of these two multiply together. So let's start simplifying. So 5 factorial is the same as saying 5 times 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. 5 minus 3 is 2. And so 5 minus 2, which is what we have written here, is 3. And 3 factorial is 3 times 2 times 1. So let's cross out what we can. 3, the 2, and the 1 will all cancel. And so we're left with this 5 times 4 over 2 times 1. Okay, so what happens on this side? 6 times 5 times 4 times 3 times 2 times 1. 3 times 2 times 1. And then 6 minus 3 is 3. So again, we have 3 times 2 times 1. So this cancels, and this cancels. And we're left with 6 times 5 times 4 over 3 times 2 times 1. Okay, let's see what else we can do. So I'm going to rewrite it to make it a little bit neater. 5 times 4 over 2 times 1, sorry, is not equal to, times 6 times 5 times 4 over 3 times 2 times 1. Okay, so we can simplify here. 2 goes into itself once and into 4 twice. And we can do the same type of thing over here, where I take 2 into itself once and into 4 twice. And I can do 3 into itself once and into 6 twice. So let's see what I have right now. 5 times 2 over 1 is 10. Times 2 times 5 is 10. Times 2 is 20. Over 1 is still 20. So 10 times 20 is equal to 200. So question 50 asks, if there are 3 unbiased coins that are tossed, find the probability that they are all heads. So essentially, what you have to do, well, there is more than one way to think about it, but I'll show you the intuition behind it first. So you have 3 coins and you toss them. What can you get? Well, you can get tails, 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 or you can get tails, heads, tails, or you can get tails, head, head, or you can have all 3 be head. Sorry, I should be separating this better. This is 1, 2, those are 3, that's 4. You could have heads and then tails and tails, or you can have heads, tails, heads, or you can have, let's see here, 1, 2, 3, 4, 5, 6. You could also have, what haven't I, which one haven't I done yet? You could have heads, heads, and then tails, or you could have, oh, there's got to be at least one more. Let's see here, tails and heads, then, oh, I know I'm missing one at least. And I think it's tails, tails, and then head. Okay, so there, counted for all of them. But that can be really hard to do, as you just saw. So what you can do instead is think of it this way. How did I achieve this? Where's this coming from? So essentially you have, for the first one, you have 1/2, right? So what is the possibility of flipping a coin and getting a heads or tails? It's easy for you to say it's 1/2. If you have 2 coins and you flip and I tell you what's the possibility of getting all heads, it's actually times 1/2 again. And so the thing is, the probability of getting all heads is 1 out of all the possible situations. And so that's why I listed them all out here. We have 8 possible situations, and the probability that they are all heads, well, there's only 1 of those occurrences, so 1 out of 8 would be my answer. But I could also get there easily by saying 1/2 times 1/2 times 1/2, which is 1/8. And so you know, you can look at the two and convince yourself of why they match up together, but definitely make sure that you understand this, because this is much easier than trying to write out all possible sets of information and then picking one out of them.